Am I live? Let's check out this shit. Twitch, tell me. Hey, look, recursion. There it is. 4, 5. Looks like it's working, actually. Yeah, you can hear me. That's good. That's good. Everything looks like it's going well. Hopefully I didn't just, like, dox myself with the Twitch dashboard. But, it should be good. Let's do this. I want to beef Viper in the Discord. By the way, the Discord probably should make the announcement. If you want announcements every time I go live, be sure to follow on the Discord and ask for the notifs role when you join in general. And be sure to wave. I will all wave at you when you join. It'll be a ton of fun. And there's all sorts of discussions and jokes and lengthy discussions in the off topic about all sorts of things. So yeah, come join. It's a fun community, and we all love having you here. Be sure to join us. Anyway, how is everybody doing? We're going to get started on some compiler work today, but first, somebody posted in the code review an XML game engine, which looked kind of interesting. It's not the easiest to build, but it is very doable. And you can see that it's a game engine. Sorry, says, yep. What's up, Sarade? It's a game engine that basically allows you to declare games in XML and collisions, and there's like a whole... It's very complicated. I don't even know, to be honest, how this is doable. Sorry, it's not the easiest to build. Yep, can attest to that. Yeah, I didn't try. I could, but it doesn't go well on Windows usually. That's the C++ is fairly well written though. It's very well written. It's like the opposite of the C++ I write. It looks very cool though, how you can just define games in just 100 lines of like XML. Like these are all complicated games that took thousands of lines of C code to work. And now they're like, yeah, you can write those in 100 lines. Isidir says, hi. But yeah, I thought this was really cool. And you should go check it out. The link will be in the description. And I think it'll be, upgraded as time goes on. Viper seems like a dedicated person. We can hope. This is what they wanted to show. And it's been shown. I don't need to show you SATA stuff. That's for the OS. I'm trying to write to SATA drives. Turns out it's very hard. No, it's not that hard. I should be able to do it. It's just like there's a million acronyms. I'm glad everyone is tuning in. Thank you so much, Isidiush Sarade. I'm glad we are all here and ready to get going on this nonsensical intercept language. I mean, it's sensical. It's just made by me, so, no guarantees. What do we have? Let's just do it. We're going to dive in. First of all, we're going to check, do I have a bunch of crazy changes? Am I down with upstream? PogChamp from Dagger Fury. I still have to add that as a emote into my little package. Yeah, we're good. I just have a bunch of test examples. Okay, should be good. We're gonna fetch all remotes, make sure I got everything going good that way. Yeah, we seem to be just fine. Okay, TNT Master says 4 minutes late. Well, I am about 10 minutes delayed, just in general today, so I wouldn't worry about it. TNT Master says, oh, we're back with Intercept. Yeah, I work on them all the time. Isidiush says, Lens, when are we building GPT-5? Stonehenge face. Not Stonehenge face. What is it? I don't even remember. Easter Island. Jeez. That took me too long. See what I mean? 10 minutes behind. But yeah, we are back with Intercept today. And I think we're going to be working on something in the x86-64 backend to start off with. And that is the horridness that is parameters. Currently, we're kind of cheating, and we just pass things in registers. But that's not how it should work. In case you haven't noticed, this doesn't go well. Isidue says it's called an MOA, a MOA. I may have that may have went over my head. I missed something. So, ideally, we could pass structs and arrays to functions. Or we could just pass more than 4 things. Because currently, once we run out of argument registers, we just kind of say, yeah, we don't do that. Right? And that's not ideal. And an even more confusing thing that I've noted is that these are not in reverse order. We're going to encounter IR parameters in forward order, like the first parameter, second parameter, third parameter, etc. And when we pass things on the stack, we need to do that in reverse order. So, for parameters, we're going to have to insert the allocation instruction on the stack before the previous allocation. So we're going to have to keep track of that somehow. Am I crazy? Basically, when we lower in the x86-64 backend, we need to figure out the ABI as well. That's another thing we can just add right now. And basically, that's a little big. Basically, oh, I don't have my my window up. That's what I forgot. My trusty, oh nice, it's a little off. Hold on. Blink. My trusty companion. I don't think there's a white line on top. Am I good here? I feel like I'm good here. Is it just basically Lens 2023? Yes. Okay, so there's a calling convention that we're going to have to follow here. What is it called? I don't have company mode on. Duh. Okay, we do have context. And, well, that's not in the right spot. Don't worry about that. I think we got to worry about call convention. And then, is it call conv? I don't remember. Yeah, call conv. Oh, those aren't in the right spot either. Let's go Linux. Then we're going to say to do x86-64 backend doesn't yet support passing arguments on the stack. According, I know you can't see this, to the sys5 ABI. Sorry. I feel like that's fine. We could probably just do a switch here on the call convention, but there's only 2. We'll do something like this and say else. Still keep that there just in case. We don't want to get through here. Doesn't yet support passing arguments on the stack. Nice. That's fine. According to the x64 MS ABI. Sure. Those are probably in the wrong order. Very cool. Now let's just see what happens. Hopefully the right thing. Oh yeah, something else I wanted to mention. VIA got an update. Oh, man, did it. Look at this beautifulness. It's my keyboard. It's now a 3D renderer for reassigning your keys. It's pretty sweet. And it also tells you all the errors in your firmware. Isn't that beautiful? It's very cool. I'm sure I'll figure out how to fix those eventually. But yeah, this is my keyboard, and it actually works now with the QMK keys. It can show me what they are and not just break. It's very nice. Your keyboard has errors? It's in the lighting, yeah. It's just VIA. It means that VIA can't communicate with the lighting, and it doesn't work. But that's because it doesn't have RGB light loaded in the firmware. It has RGB matrix, which means that it can be reactive when I type on it, which is what I like. And I don't care about the, like, you can make it a rainbow circle or a spin wheel when you want. It's like, I think it's cooler when it's reactive. And it saves energy because most of the lights are off most of the time. It's only when I actually press the key that the light goes on. It's very cool. It was a cool update. It looks much better, and they have a link to the GitHub and the docs and the Discord built in. It's just a very cool overall thing now. They did a great job, and I love using it. Anyway, thought I should mention that. What was I getting to? Was I doing something? I was in the middle of something, I'm sure. I was gonna run an intercept thing, and basically see where we get to. Because this should trigger that. Perfect. Okay, what do we have here? I'm gonna do this. Sure. What does it say? Doesn't yet, according to MS60. Okay, it worked. We got to the right spot. I did it right. Hooray. We can see all the wonderful printouts because of my command with print AST, debug IR, annotate code, and -v. So we get quite the chorus. And as you can see, the AST is of this file, which I will now check out. Load my mode. And this file is actually, that didn't work well. This file is actually an intercept file that is meant to interact with SDL and link with SDL. And it's hopefully able to enter the event loop and wait for a quit event and then quit. This is mainly taken from LazyFoo, if you've seen those tutorials, because I figured I don't want to like copy my code because it might be more complicated than it needs to be. I just went to the simplest tutorial I could find that works in C and tried to get it working here. It's actually works pretty well, surprisingly. Obviously, we can't just use the SDL headers, so we have to define everything ourselves. But it actually doesn't look too bad. And once we get like modules or file includes or whatever that system ends up being, it's going to clean up nicely. It really is. And we can do some bit shifting with some an array, a data array. So this feels good. We don't have unions yet, so this is what we have to make do with. Don't worry about it. And basically, we just go on to create a window. And the problem is that SDL create window takes 1, 2, 3, 4, 5, 6 parameters. And the x64 ABI only allows 4 integer-sized parameters passed in integer-sized registers. Whereas the Linux ABI sys5 allows for 6. And then there's more. If you have floating point arguments, you can use up to 8 floating point registers. Silver Felix, thank you so much for the follow. But yeah, another thing I should mention is that, oh yeah, so this, to to-do we're hitting is for this SDL create window in the backend, trying to lower it. Another thing I've done, Zariel says easy, just use Linux, clueless. It's true, but even Linux, we're not following the sys5 ABI correctly at all. So that would be another thing that we can work on. Another thing I did is I wrote a test runner that takes advantage of C-test, so you can now do parallel testing, which is so much faster, especially on slow machines like mine. And it orders them in the fastest possible way, which is very cool. It has this complex ordering mechanism. And you can see it says the following tests failed, and you can see that these 3 failed, and here's where they are, which I feel like is very nice. Tells you how long it took. And each one that fails, it actually will tell you the output you get. And you can see we're getting more stuff like this, arrays as parameters and such. This doesn't test the optimized versions like the Algol suite. And you can still run the Algol suite, which I recommend. It's just a little slower right now because of developer inadequacy. But you can see that it actually is a little bit better because it tests unoptimized and optimized versions of each one, reports it as it goes, and at the end tells you how many were skipped versus how many just failed or errored with an ICE. So the Algol suite is much stronger and more robust, and it is what we should use mainly. But for quick testing to make sure you didn't break things. The C-test suite is much faster because it'll quickly report, hey, you broke everything, or not. But still, we should use the Algol suite if we're going to like merge a PR or really check something. Just figured I should mention that. Okay, where were we? MS64 ABI. Well, what do you know? When we're dealing with it, we're probably going to have to read their documentation, aren't we? Let's check it out. Let me get everything on a separate page. Perfect. And we can check out the calling convention. It's going to suck. Parameter passing. Passes the first 4 arguments to a function in registers. The registers used for these arguments depend on the position and type of the argument. Perfect. Remaining arguments get pushed on the stack in right to left order. Sir Aid says that's a long AST printout. Yeah, yeah. No arguing with you there. SDL event type is quite complex for short syntax, which I attribute to intercept just being elegant. Right? You can write things quite easily in a short time that amount to a large amount of actual work done. Right? We'll go with that. Zaria says, at least it looks cool. Yeah. I do kind of just like looking at it. And it makes sure that we can debug things and go back and look if things are broken. Okay. So if you don't know, it's kind of confusing, but if your first argument is an integer, it'll go in RCX or an aggregate or a pointer. Yeah. It'll go in RCX. But if it's floating point, it'll go in XMM0. But here's the thing. If your first argument is, for example, an integer, and your second argument is a floating point, it'll still go in XMM1. You can't use XMM0. Does that make sense? It's a horrid calling convention. But here, oh, here it is. So here you can see an int, A goes in RCX, double B goes in XMM1, and then int C goes in R8, right? Not RDX. It's not the second integer, it's the second parameter, and that goes in RDX. So no matter what, you can kind of like increment this table equally. I don't know if I'm making any sense right now. Luckily, we have some examples, so this is good. I don't think we can really write tests to figure out which register something ends up in yet. That'd be a complicated test. So we can just manually verify that things like this work. And we don't have doubles or XMM, so really we just have to worry about the stack thing. We're kind of here. So when we look at, this is small. It's zoomed in and it's small still. You hear the airplane? Jesus. I have the best timing. It's like they're doing an air show over me apparently. What are we doing? So right now we can do this amount. We can say, oh yeah, A, B, C, D, we got it. We're cool. But as soon as we get to E, we are reaching this code path that says IR parameter instruction immediate is greater than argument register count. This is basically the parameter number, the index. This is needed because technically you can reorder SSA and it should be fine. So this tells us what parameter we actually are on. If it's greater than or equal to the argument register count, which on MS-Win is actually 4, as we just read. So as soon as we get to the fifth argument, which has index 4, right? Then we end up here. And this should be confirmable. We just print out the instructino, the instruction. Just called instruction. And it should be perfect. It says parameter number 1. Okay, interesting. So this actually has to do with, let's look at the example code. We're getting to a function. So is it event type? It's probably event type. Event is larger. It's 128 bytes. So event is larger than a register, and it says we don't actually know how to pass this. So that's fair. So it gets to the first parameter of this function and says we don't know what the hell to do. I feel like that's a good start. It's kind of a complicated one, but why not? I still haven't fixed the giant eyes in chat, and I almost kind of want to keep it at this point. It hides Surade's colons. He always forgets. Twitch doesn't use that. I do the same thing. I never know what format any emoji I should put. Like, do I put the colons on both sides and then type something in the middle? Do I put a colon then type something in space? Do I just type the thing? It's so confusing. And Twitch has gone through so many changes. But yeah, so we are not even here yet. We just are, what is aggregates? Can you describe what aggregates? Yes. Okay. M128 types, arrays, and strings are never passed by immediate value. Instead, a pointer is passed to memory allocated by the caller. This is gonna suck. Structs and unions of size 8, 16, 32, or 64 bits, and M64 types. Is that intrinsic 64-bit vector type? That's for SSE, ignore that. That's what I figured. are passed as if they were integers of the same size. Structs and unions are passed as if they were integers of the same size. Okay. So passing struct slash array arguments this will be good. Okay, we're just mocking it out. Yeah, this is going to be horrible. I'll leave that to do there for now. I'm not going to touch it. Let's just see what we get to. Okay. So basically, if it's a struct or an array, we should be going... do I have to use the canonical type here? Why are we not reaching something here? Because SDL event is for sure a struct, right? Am I crazy? Shouldn't we be here? Maybe I need a canonical type. What is the type? Let's just print the type. Generally, you should probably always use the canonical type. Proposal. Can we make it where the type here points to a canonical type? Instead of, at what point can we do that? Can we do that after we're done type checking? Can we like lower everything to its canonical type? You can do that in code gen. I see, so like before we code gen the instruction, lower it to the canonical type. Honestly, it might be worth it to not have to do it everywhere. Let's just do it here for now. In codegen.c when creating the instruction. Ah, I see. So I see. So set the IR instruction type to the canonical type versus the actual named type or whatever. I think that would make sense. That way the IR has as few types as possible and as simple types as possible. That way we don't need a named type foo if it's just an array of integers. We can just say it's an array of integers. I don't know. We'll think about it. It's gonna kill me. Oh, I can use my fancy trick. Query replace instruction type with type. That one and that one. Type size I've already does it, but might as well do it. Okay. That makes much more sense. So it was a named type before, which means we didn't catch this stuff. Beautiful stuff. Okay. Now, passing struct slash array arguments, it depends on the size. So really, we just want to say and type size, because otherwise we just want to use the register, right? So we kind of just want to fall out of here unless the size of the type is greater than 8, which is the max register size. I'm just going to write that. But that's only for this calling convention. Maybe 8 would be better. Because they specifically say 64 bits. I may want to quote this. That's probably what I'm going to do. Yeah, I'll just separate this. Sure. So if we're passing a struct or an array and its type is greater than 8. Also, this doesn't say arrays, which I worry about. Okay, arrays, strings. Okay, we're just gonna add all this. Why not? We're under MIT here. We don't give a shit. Types, arrays, and strings are never passed by immediate value. So arrays don't need this size of check, but structs do. So it says that doesn't matter for us because our arrays should be passed like structs. What? Is that true? Do we want to do that? Arrays means C arrays. Yeah. Don't we have C arrays, sort of? I mean, I guess... Sorry, it says no. C arrays are passed by reference. Ours are not. That's a good point. That's not the default. If you would declare an array integer 2 as a parameter, it shouldn't. You should get a local copy. That's okay. So yeah, it is like a struct. Damn. Craziness. So I'm just gonna note exactly this because I'm gonna see this in the future. I don't know why this is broken. Indentation. The same goes for strings. Yeah. Arrays and strings in intercept are passed like structs in C, so this doesn't apply to intercept arrays, strings. Coolness. That'll save me in the future going, wait, isn't this wrong? And then spending 40 minutes going, wait, why'd I break everything? Because our strings are just byte arrays. That is correct. We still got to worry about new lines. Figure out what to do there. Or if we want like a pragma to change string new line captures. I don't know. It's difficult. So when we emit this instruction now, we kind of know that we need to do that. So it says structs are unions of other sizes. So I'm just going to pop this in here too. I'm going to go ahead and do a ... Structs or unions are passed as a pointer to memory allocated by the caller. So, effectively, says, are you the guy who posts 6-hour-long YouTube videos daily? Missed ya, 19 lol. Is that, let me check OBS. Oh, interesting. I like new emotes. Very beautiful. Sorry, 9-hour-long YouTube videos. I did just break my record, I figured out. That was my longest video, 9 hours and 15 minutes or something. And then I realized that YouTube won't allow me to post anything longer than 12 hours, so I gotta be careful. Sorry, it says be right B. Okay. Be right B. I don't know what I just said. BRB. Yeah, he'll be back. He'll be back. We'll be okay. We'll miss him dearly. Structs or unions are passed as a pointer to memory allocated by the caller. So, we are a parameter instruction, a measly little parameter instruction. What do we have? What do we have? So, how do we know what the caller is? There's going to be multiple callers, presumably. One option would be add this. Okay, I'm just going to start writing this down. Option 1 at each function that needs parameter fix-ups. I guess we don't even need to do this. We just need to say each time we encounter a call, fix them up in the same way. So this is a mess. This is a mess. So we need to figure out how many parameters there are and do this for each parameter. Okay. Because Baku says, you making a compiler? I would say I've made one. I'm working on a compiler on making it better so that we can pass struct and array arguments. But I'd say I've made one. It does a lot of stuff. We can see, for example, like, what do you want to see? Downwards fun arg. That's, I've broken something. That's wonderful. Oh yeah, because it's a, we're probably calling size of function here and it's doing crazy stuff. Wonderful. We have, what do we have? Oh, new lang or new implementation? New lang, I made it up. No life fact bot. Hey guys, what's up, no life facts bot? I'm sure you're doing well. But yeah, we have casting. We have rule 110. Hopefully that still works. Nope. It just always goes to this. I wonder what I broke. Else if blah and type size of type is greater than 8. Where are we reaching? If type size of type is greater than max register size. Else if, okay, and greater than equal to argument count. But there's only one here. Which is a little confusing because you would think that we would just make it to here. Are we saying according to the MS? So we're actually reaching right here right now. Even though instruction, so what's is argument register count not being set somehow? It really should be, it's being set. In codegen lower, yeah, before we call lower, so we should be good there. And it's being set to MS win register count, which is 4. Just to double check everything. Just finished my uni assignment, so I'm glad that's over with. So what's the language you're working on about? Or is it just generally a project because you could? Originally it was called the Fun Compiler, because I made it for fun. So I would say it's definitely like I made it a because I could project. There's not like some overarching motive behind it or anything. It's just an open source, educational, hopefully, compiler that you can actually watch the development of online. Almost all of it. Fell off the bandwagon a little bit, but I don't think you need to see everything anymore because it's a lot of nonsense. But yeah, hopefully that makes sense. But yeah, it's just, I didn't really have a plan. I went ahead and started making this compiler from scratch in C anyways. And here we are. Rust compiler asks, does this use LLVM at all, or do you generate backend yourself? I wrote this backend myself, but the compiler is backend agnostic. It generates an IR. So you can write an LLVM backend if you would like. Speaking of, Saraid is back. And Saraid, they're asking about, does this compiler use LLVM? It doesn't. It generates x86-64 assembly. Just because that's what I wrote. But I made it backend agnostic, so you can easily write another backend and have it support that. In a few thousand lines of C code. Saraid says, the IR is similar to the LLMR IR, though. I don't know what LLMR is. We were just realizing, sadly, that instead of tracking down all the calls when we get to a parameter and allocating for it, we can just at every call allocate the parameters if we need to. Sraid says, I can't spell, okay? Okay, he meant LLVMIR. That's what I thought. I just wanted to make sure I wasn't missing something. No Life Factbot says, at home, Kappa. But yeah, Sraid, that makes sense, right? So that we don't have to like recursively loop over the instructions 80 million times. We can actually just do it to the calls as we reach them. Problem that I'm encountering, we don't know, like, do we just insert the allocations before the call and hope that that's fine? Is that kind of where we're at? Like, do we just use insert instruction before, I guess? We'd probably have to do that. Sure, that would work. Okay. Because allocays are merged anyway. That's what I was thinking about. And I was worried, like, does it even matter where we put the allocays? Can we put them all at the end? Like, I obviously not at the end. It has to be a branch instruction. But you know what I mean? Okay, so we have to do this whole check every time also on calls. Yeah, which is kind of crappy, not gonna lie. So we just need this part here. But here's the thing. We can kind of do an optimization because we don't have to go through each parameter. We probably have a number of parameters available in the call itself, I would hope. We have arguments, and then we can do size, which is a size t. So, oh, what did I just do? Jesus. Don't do that, whatever I just did. Size t, and then this is going to be arg count or something. If arg count is greater than or equal to argument register count, then we're going to have to lower push onto the stack is step 1, right? By the way, this isn't the horrible part when it comes to parameter passing. That would be var args. Yeah, we might just not support var args. I've been thinking about that. I think we might have macros that look a lot like var args because it does currying effectively, kinda. Because lambda calculus only ever has one argument per function, and they get away with mimicking that with currying. And I was wondering if we already support n amount of arguments per function, so obviously we can curry 80 arguments into a 4-argument function. That was my idea. If we're going to do var args, we're going to do like a currying style Haskell instead of the horrible var args nonsense. If you want to interface with var args, I don't think intercept needs to do that, because the only place we would use it is printf, and the ideal is that we're basically going to write our own printf and have our own functions like that, because we're going to have our own standard library eventually. So printing can be part of that. So it says, sure, having something like C++ variadic templates would be preferable. Oh God, what have I done? No. No Life Factbot says, what about partial application, or do only have currying? Well, if we have I think those are two separate things. Partial application has to do with like macros and quoting and unquoting, because I'm from Lisp, so I wouldn't worry about that. We're not thinking about macros here, just var args. But we might have to interface with C-style var args at some point. I mean, in that case, it'll be like a custom compiler extension and under like __ vararg have to. You know what I mean? I don't think we should necessarily go for that. As in, I'm not saying our native way of having variadic functions should be C-style varargs. So I think that we should be able to apply our currying style to a C-style vararg in some way. I think it should be that. It's just like And then we also are going to have like macros that run at different times. So I was thinking like maybe we could have an AST level of macros and then also a lexical level of macros, the token level. So like you could have a macro that just receives a list of tokens that you iterate through and can add to and remove from. And then the AST one, you can like move around the tree and do all that nonsense. That's going to be really complicated in the future, but token macros would be more like C LaTeX macros. Exactly. And then AST macros would be deeper. Oh God, excuse me. And AST macros would be more like code that runs at compile time. Exactly, because you can replace the code with other code. It'd be like a Lisp macro. Surreyed, yeah, or more like Lisp macros, I suppose. You have it exactly right. That was my idea. Like, I can get both macros. And I think the C-style macros are really important for like conditional compilation and stuff. And a lot of stuff, really. Just replacing, making things easier, like to do. I don't think this, you know what I mean? This doesn't necessarily need to be anything, but... And then if you have a macro that takes in like a variable amount of things and then can apply them over time to a list, or get them in a list and then iterate them in a certain way and use them, I think that would be ideal. C-style macros can be useful for situations where what you want to do can't be tersely expressed in the syntax of the language, because that happens sometimes. I'd say often, oh yeah. I also was thinking about postfix macros, where you can take in one token or you can take in one AST node for an expression, and then you can like change it. So it says, sure, yeah. That'd be like LaTeX macros. Yeah, kinda. But I was thinking like it'd be similar to like plus plus. Like it's just a postfix operator, but it actually changes the previous thing with the macro that is like for this type. You know what I mean? Like you can define a bunch of macros of all the same it'd be like operator overloading, but generically. I don't know. I've got a lot of ideas. First, I should get it working. C macros are also known to be a bit of a foot gun, though. Maybe. Postfix macros sound a bit annoying to implement because of look ahead and all that. That's true. We could do prefix macros. I guess that's fine. That would make things a lot easier. It doesn't really matter to me. It was just like a little decorator that goes at the end or the beginning, I guess. Because if it's like dollar and then this gets changed or something, and that would fix the dollar being a variable name. So for SDL event, for rule 110, we should be able to compile it, but it says no, no, no. So what have I broken? It says we're calling something. Have I just copy and pasted into the call something, a to-do at the top level? I don't see a to-do at the top level, but I do see that we aren't breaking. That would definitely be a little bit of an issue. Okay, that wasn't it, apparently. We're apparently getting here. Because we're doing all these checks that we really don't need to be doing. So really, I feel like maybe should these be in reverse order, but this is only for, yeah. So at this point, we should probably switch on convention. But then we also have to check for just struct arguments. So no matter what, we're going to have to loop over the argument. So let's just do that first. Right? Let's do our for each. What do we have? What is this? For each needs vector element type. Type element vector. I got it completely backwards. That's incredible. I don't remember the type right now. Maybe it's member, maybe it's argument, maybe it's node, or IR instruction. It's probably a pointer, so we need for each putter. And then we can do this. Maybe it's an IR call argument. Prefix macros is exactly LaTeX macros. E.g., instead of text@f, you can just do /text@f. The braces are just a way of grouping tokens. It's just like a C++ ranged for. For type name : container becomes for each type name container. Yeah, I'm just bad at remembering that. Name. This can be anything. We'll call it argument. We'll go with the full thing. This is the arguments vector. And basically, we're going to have to do different things based on the ABI. So I feel like I should just do that here. Well, yeah, that was smart. Jesus. I'll get there. Maybe. Okay. I should really rename these to like sys5 and x6 msx64 or something. MSWin is fine, I guess, but sys5 would make more sense. And basically, on Linux, there's like a recursive algorithm that we're going to have to do. So we're just going to not do that. Sys5 recursive algorithm stuff. x86 64 backend doesn't yet support. Sorry. Perfect. So we're going to need the canonical type of this argument. Jesus. And if this is a struct or an array, and so I guess I need to group these. And the type size of type is greater than 8. It's going to be a mess. Okay, you're going up here. Okay. Then we need to basically insert allocates, change the type of the argument, and maybe that's it. Yeah, maybe that's it. So change the allocates. Let's think about this. So we need to basically insert an instruction before the call instruction. And the instruction that we want to insert is an allocate, and the allocate is an instructaton, which is, how should I do this? Maybe I should do it this way, because I don't want to insert it. I just need allocate irs, probably allocate. Allocate type is going to be equal to an AST. It's a little cursed using the AST functions in the CodeGen backend. It's going to be a pointer to the, by the way, we're going to need the AST, so let's pass that in there. AST make type pointer. Basically, we need to make a pointer type to, what are we allocating? This struct or array, this type, which is actually argument type. Okay. What did I miss? Source location. Sure. Argument type source location. Why not? We insert this instruction. We should probably also set its size, which means that we need to set the allocate size. We will hopefully calculate offsets later. If not, everything is going to be real messed up. We could cache this, but I'm really not worried about it. What else? Well, I guess what else is that we really just have to replace the argument. What is the argument instruction? We don't actually know what instruction type this is. So can we just replace argument? And instead of doing this, can we just say argument kind equals IR allocate? Not equals equals, obviously. Can we do something like this? Can we set the type to this? You know what I mean? A little, and then just, we don't have to do anything, right? We're kind of good. Should I try and replace it, like insert the new instruction and do all that, or should I just reuse it? Because I don't see really a use having to do this thing. So we want to replace uses of argument with uses of allocate. Then we want to remove argument. Sure, let's replace the IR immediate 4 with an allocate. Am I thinking about this wrong? This is a struct or an array that's larger than 8 bytes. A struct or array larger than 8 bytes. It's just going to be an IR load, right? Or a copy. Or an allocate. That's a good question. What if it's already an allocate? We can just pass it. We don't have to do anything. Otherwise, you're replacing the value with an allocate. That's a good point. I haven't copied anything into this allocate. Where do I copy from? Argument. Okay, I'm getting it now. So I can't I do replace uses, right? And then I use argument. Do I not replace uses? Is that wrong? Oh God. That is wrong, because I don't want to replace all uses of the argument with an allocate. So, but I do want to replace the uses in parameter. Right? Am I wrong? Or in... no, this is the call. So this should just be... Do I need to actually replace the element in the vector? I'd say the safe way of doing this is, if it's an allocate, just pass in the address. Otherwise, allocate a copy, store into that copy, and replace just the argument with the address of the copy. And by copy, I mean the allocate that holds the copy, not an IR copy. Actually, no. No. It's passed by value. So forget the first part. That's what I was thinking. We're going to need an allocate because we need a local copy that they can modify. So I need to insert another instruction is what you're telling me. But this instruction is a different instruction. It's a store. With the address being allocate and the value being argument. Hopefully we then are able to lower this store. But otherwise you're going to forget about things like usage marking, etc. I'd recommend using IR store, etc. Isn't that going to insert in random places? We don't really want that. And all these closed blocks will just break things. The problem is insertion, yeah. Yeah, I've ran into this. I think this is the cleanest way for now. Until we separate the IR API into IR don't insert and IR do insert. How do I mark used? User allocate store argue store. Yeah. In C++, you could just make a create and an insert template, but in C, you have to do that manually. Yeah. It's true. So where are we at? Basically, we insert this allocate and store. Don't we then have to replace the argument itself? Don't we have to say like star, almost like star argument equal, like we just have to make this in the vector point to a different thing. How do we do that? Is that illegal? Neutrino says, are you using LLVM IR? Sorry if it is a noob question. We are not, but it's similar. It's our own home-baked IR. Because what I'm worried about is that when we then emit this, we're going to need the argument. Don't we get the argument down here? Do we never do that? We just do argument registers. Maybe the argument has nothing to do with parameter and we can kind of just ignore that and don't have to track everything down. That'd be nice. So are there no uses we have to replace? Like what actually uses this store or this allocate? Where does this get touched? Don't we have to somehow correspond this argument to this allocate? Because when we emit it, we're going to need a pointer, and the pointer's the allocate instruction. It's, by the way, Neutrino, it's not a noob question. We like all questions around here. Sorry, it says, if we were, we wouldn't have to deal with this nonsense. It's true. It'd be a higher level. Why are you mad? Call conv count not handled in switch. You can deal with that. Also, first time chat from Neutrino. Welcome to the club. Welcome to the club. Thank you so much, Neutrino, for the follow. I also apparently missed that at some point. My bad. Lol, the pain of 100% homebrew. Pretty much. Where are we at? So calls. Where do we actually use this allocate? So can we actually just run this and see what the hell happens? I don't think we need all of this stuff anymore. Oh, nice. I fixed something, apparently. Pog. Rule 110 works. Once more. What was I testing? STL2. We still get here. What do we end up with, though? I guess if we're looking for a call to SDL event, do you see one? That's in SDL event type, so no, we won't. Here it is. So we have load of 28. This is before it was lowered. So if what we can do is this. instead of omitting the instruction, let's just omit the whole thing. So it says to do prints the line number, right? Yeah. Call. Okay. It seems to have worked. If you don't know what we're looking at here, it worked really well, actually. I didn't expect it to work that well right away. We have an alloc of 128 for the struct SDL event, and it's a pointer to that because it's on the stack. We get 2 pointers to integer, which is just to copy over. This is a mem copy, basically. And then we just have a manual mem copy where we store integer pointers into each other, and then we add 8 to each address, and then we keep going until we get through all 128 bytes. Legendary. Really got to turn that into a for loop. Cool. We still have 37 here, so when we call 37, what is that? That's now the alloc. I don't know how that happened, but that's wonderful. That's exactly what we want to pass, so I'm not going to touch anything because apparently I did it. What? Did I recompile? Yeah, I cleaned first. Everything recompiles. Well, that's what you call a miracle right there. Cool. Sorry, it says unrolled at compile time, Pog. It is. This is the IR. It's legendary. This is the fastest language. So it says, wait, is everything working now? I mean, we don't actually lower the parameters, but as far as passing argument, as far as passing structs or arrays, I think we did just do it. But I don't know how. Can you help explain how? How? Sorry, it says that's already half of it. Nice. I know, it's only been an hour. It's like 2 minutes of work in reality. 1 hour of streaming, 2 minutes of work. Or what was it? What was our ratio? It was pretty low, I remember. So, I mean, this should work. We're passing an integer pointer now to SDL event type, or a SDL event pointer. Sarade says 3 hours equals 10 minutes. That's what it was. That's what it was. It's pretty accurate, too. We really got to fix this static ref situation. Another thing I'm worried about, Sarade. I know we never get to code generation. String literals may be crazy amounts of bytes, and I don't think we do any padding in the actual generated code. So I think that the address of a string literal might not be aligned. Is that allowed? I wanted to ask, do we have to like 8-byte align these? Because if so, we really messed things up. Right? And that's another thing we're going to have to lower. So it says no. So a string literal can just be at byte has an alignment of 1. That's an interesting way to look at it. So a byte array has an alignment of 1 as well, presumably, because an array has an alignment of the base type. Because it's basically just a struct where every member is the same, and a struct alignment is the largest alignment of all of its members. Okay. Okay. Just checking. And an array of bytes has an alignment of 1. A pointer to byte has an alignment of 1. Arrays are always properly aligned. Interesting. Byte arrays, I think you mean. But yeah, that is a good point. A byte array can't be misaligned. Because for arrays of structs, we make sure that the size is a multiple of the alignment. I see. That broke my brain for a second, but yeah. Yeah. Cool. Cool. By the way, the reason this worked so fast is because I wrote lower store and it works. It basically, I wrote how to emit a mem copy in the IR from addresses. It's a real mess. So it says arrays of any type are properly aligned because the size is always a multiple of the alignment. Yeah, I see what you're saying. Unless we had align as or pack structs, of course. That at that point it gets more complicated. Very complicated. I don't even want to think about packed structs. It's like, if you want to work with hardware, good luck. We're getting there, okay? We're getting there. But for now, we're not even thinking about that. That's rough. So let's say calls, half of it is done. But we're going to get here and say call to function with more arguments than are currently supported. I'm not worried about what this says. And now I'm just curious if we reach that. We do. What actually is the call? It's the call to SDL create window. Okay. That makes sense because that's before this. So this is another thing we have to deal with. And it's also different per ABI. So we're going to want to steal this little keeper. Doesn't yet support sys5 stack arguments. Sorry. Oh boy. This is going to get rough. So basically, the thing of it is, we need to push these onto the stack in reverse order. What does that mean exactly? So F then E pushed on the stack. So this means we have to loop backwards over the arguments of this instruction until, okay, usize I is going to be equal to size minus 1. We're going to do minus minus I, and we're going to say if I is less than the argument register count. Is that how that would work? So let's see. So argument register count is 4. That means if I is 4, we still need to do that argument. So yeah, so if it's less than, then we break. Okay. So we loop backwards over each argument. Let's just make sure that this works. Beautiful. Okay. So we get 0 and 480, and if we go up to the actual, what's that? If we go up to actual call, we can see that we have 0 and 480. And before that, we have 4 other arguments. So these are passed in registers, these are passed on the stack in reverse order in the order of 0 then 480. So we need to generate an allocate once more. An allocate and store, right? We're kind of doing the same thing. Are we? Saraid, am I getting this wrong? We're kind of doing the same thing where we make a stack allocation and then store into it. We need the canonical type, ideally, I guess. Which we can just use the argument type. We're not quite doing the same. Okay. So we make an allocation and then we store into it. One thing I've noticed, are we inserting the store? I feel like we may want to insert the store. It may be important. I don't know, maybe I'm missing something, but I feel like that may be important. For things that were already copied in the caller, we don't want to create another copy. We do create a local variable for the pointer itself, though. Another thing I just realized. Is that if index is greater than or equal to the argument register count, then this can just be handled elsewhere. Right? We only need to go over the few that we need to go over, because the rest will be handled on the stack here. Is that what you're talking about? Is that not what you're talking about? If that's not what you're talking about, I can understand. For things that were already copied, like, so are you saying if it's already an allocate? But we do need to create a local copy for the passing. The call, okay, hold on. So if you pass an SDL event to a function, the caller allocates a copy of it through up here and passes a pointer to the copy, so an at SDL event, and to the copy. Passes a pointer of it. The caller allocates a copy and passes a pointer to the function. Yeah. So a pointer to SDL event, and the callee allocates a local that stores the SDL event. Yeah, we're not in the callee. We're still in the call. But we're still just dealing with more arguments. This one, F then E pushed on the stack. A pointer that points to the copy is passed to the function. That's what I meant by pointer to the copy. I see. I think we're talking about the same thing. Basically, we loop over them in reverse order. We want to allocate these things on the stack, even if they're integers or whatever. And we want to store from the argument into those places. Is that correct? That's, I guess I would have to think about this. Did I reach call the function with more arguments? Yes. So we're reaching here. So really what I'm interested in is what did we end up with? Okay. Allocate 8, store into 21, 20. Allocate 8, store into 22, 19. Well, that looks perfect. Okay. Beautiful. And then this still has 19 and 20 as an issue. That is an issue. It almost is like I need to replace... Can I replace in element putter? What do we have? So element hash hash putter. This is kind of cursed. Hold on. Means that hash hash putter will just be that argument. So like this. What did I get wrong? Element hash hash underscore putter. What does hash hash become? Am I crazy? That like puts two things together. Element is being replaced with hash hash because of stringification. It's being tokenized as the one thing, so we get argument putter. This is cursed, right, Saraid? This is not what I should be doing. We need to replace this with the allocate. We're gonna see what the fuck happens, for sure. Well, would you look at that? It did work, Saraid. It did work. I don't think it's correct. I'm writing the argument putter from for each putter. This implicit thing in here. I'm writing to it. Allocate. Yeah? And that means that in the vector, we then go to the next one. We don't alter any others. We're not removing or adding, so there's no iterator invalidation. We're just replacing the thing we just iterated over. We may want to add something like that, but I feel like this is the way to do it, right? That only replaces it in the vector. That's exactly the only thing we want to change, because the call, IR call, needs to just have its arguments vector updated to the allocate, because we want to pass this pointer now, instead of the actual immediates themselves. That way, when we go to emit it, we know that, oh, we just need to pass these things. And yeah, the name of the pointer variable is always varname underscore putter. Beautiful. Okay. Well, that's halfway there. We got calls done, hopefully. Oh, that means we can remove this to do. Hopefully. And reach another one. Ha! Beautiful. And we should get to the point where we can call SDL event type with 39 after a long list of, a mem copy, which is copying 32, which is an allocate itself. So we make an allocate for this function call to pass by value, copy into it with registers, and then, pog. Okay, so let's say all that is code that works. What are we actually reaching? SDL event type now? Doesn't yet support passing struct array arguments. So yeah, here. Structs are onions. I really like onions. Fried onions are my favorite. Oh man, I got a Jesus. Like 5 notifications just showed up in the Twitch activity feed, but they're backdated. They're trying to gaslight me that they were there. Caligula, 612A12, I Little Big, Sparky Igniter 7, and Hells 151. Thank you so much for the follow. The follows, I appreciate it so much. We're over 300 now. We're at 308 follows, and you are a part of that. Thank you so much. I appreciate it. Be sure to check out the Discord for announcements every time I go live. You can see it's very active, apparently. Jesus. Ooh. May asks, how to get added to notifications role. That's how you get added. You ask. I also have 1K subs on YouTube that I have no idea what to do for. I may just ignore it, but I do want to do something special. I may wait for some funny number just to make it, you know, a little different from what you see normally. Sorry for the essay. Linguistics. Oh yeah, in makes no sense there, but I still do it. It's so true. It's so true. I like structs and onions. Oh yeah, you can get announcements every time I go live. Like today, I made this announcement. Ooh, poke. Okay, so in the parameter, we now know that, okay, an interesting thing has happened. A pointer type is only 8 bytes. But the parameter, do we have to check if this is a pointer to a struct or array? You know what I'm saying? Where's this type coming from? Can you emit? Okay, we do IRF init right away. So what are we actually looking at? Assuming that this is failing on SDL event. Here, why would that be happening? Well, this is parameter, so this wouldn't be at a call. This would be at the beginning of the function. We have parameter. I see, we haven't lowered its type. This is good. This is good. So this tells us that we actually need to treat it specially. That's what I was worried about. Like, oh, if the arguments are just updated, then we won't ever know. But that's only in the call. That's perfect, because this type needs to be updated to a pointer to SDL event. Also, we need to check this thing here. I think would be easier, right? So if we just check that the immediate is greater than 4, I guess we don't even need to check that. We need to do this for all of them. That's why it's separate. Do you guys like onions? I like onions. What are we doing? Struct array. Structs are onions. Okay, as passed to a. So we need to lower type to a pointer, because that's how the calls have been altered as well. We now have a pointer. Equals AST make type pointer. And this is going to be the instruction type, source location, and that's a little low. And instruction type, yeah, just instruction type. So we basically want a pointer to itself instead of just a struct or array. Beautiful. And after we do this, we actually want to emit an allocate and is this true? No, we just want to use this pointer. So for every use of this parameter, we need to add a dereference, right? Is that correct? Let's look at this now. All that's going to be updated is the type, but I just want to make sure I'm not going insane. So you can see now that parameter 1 is a pointer to SDL event, which makes sense because when we call it with 39, 39 is a pointer to SDL event. Interestingly, this doesn't say pointer struct to SDL event. So this is a pointer to a named type, but this is a pointer to a struct type. But the name type is a... I don't know why those are different. I might want to be worried about that. Okay. How are we doing? Are we doing good? Hopefully it's good. Is this true? We need to add a dereference. Let's think about this. Where do we use number 1? Also, these are confusing. Number one. Number one. Where is it? None of the references clearly. Ah. Store into 9, 1. So this creates a local copy and then stores into it from our local copy allocated by the caller. I think this is what Suraid was mentioning when he says we don't want to make a copy of the copy. This is almost definitely what he was mentioning. So we make a copy of the copy, which isn't ideal. What is this now? Allocate a pointer to integer. Add 0. That's an interesting one. Copy 12, which is just a pointer to byte. So this is a subscript of 0. No, this is a member access with 0. That's why it's not optimized. So we have a member access of an integer, question mark, at byte. Yeah, and then we 0 extend. So we allocate an integer, we 0 extend an integer into from the loaded byte here, and then yeah. So this is just the actual 4 subscripts and everything. And member accesses of event and data. So this is event data, blah, blah, blah. It's going well. Where is number 9 used? Number 9 is just used as an address. So we just need to, instead of creating number 9 and its corresponding store, where is this allocate created? Where is that allocate created? That's a little confusing. So is that for an IR parameter? I think we lower those. There's literally, that's it in this file. This is the only place we see them. Legendary. Okay. Beautiful stuff. This is going well. So for every user, we need to add a dereference. Let's think about that. I don't know if we do, because we already end up with a pointer to it as our allocation. So where does this allocate come from? Is that in here before? When does that get added? Yeah, there's still an allocate added. Is it in here? So we have calculate stack offsets, lower, allocate space for the variable, that's statics. Load from a local, store to a local. We know how to emit an allocate. We lower a load. So maybe we're lowering the load of the allocate into an allocate, which is kind of not ideal. Is that what gets originally generated? We should have... Let's think about this. An SDL event, then we allocate and store into 9.1. So this is this already generated in CodeGen? That would not be ideal. I guess at the beginning of a function is what we're really looking for. We emit all the static vars, and then evilness occurs. Oh, this is gonna suck. Suraid, are you here? If so, I would like your opinion. In CodeGen, when we emit a function, we allocate... Suraid says, Yes, thank you so much, Suraid. I'm glad you're here. In CodeGen function, we emit parameter decals and store the initial parameter values in them. But we don't need to do that because it's an array, but we only need to do this for certain calling conventions. Do I add the calling convention handling here? I feel like that'd be really messy. I feel like we should add it in the back end. Don't do that if it doesn't fit in a register. What is our parameter? Oh God. Backend should probably have an API type fits in register or something. That's kind of messy. That'd be backend specific. Should we just move all this to backend specific? That kind of feels like the wrong thing too. Kind of curious. I have to know what this is. We omitting a parameter here? It literally just returns, okay. Okay. Just checking. So we're not omitting a parameter here. This just uses the parameter. Just like how cogen emit calls cogen emit x8664, etc. So should we call like cogen function x8664? That kind of feels messy. Hells151 says, hey guys, how's it going? Welcome, welcome. 710 oil. Oh. So we definitely want to always do this. So it's as though, yeah, you could argue. This is a mess. That part of this should go in the back end. Yeah, but I don't know how. So what if we don't do this? We just need to do this in the back end. How do we do this in the back end? So when we lower, we need to like lower each function, right? At the beginning of each function, we need to go through and do this stuff, which we are already doing because we have the IR parameters here. So when we encounter an IR parameter, we can just insert instructions after it that load it, right? Okay, wait, what? Sorry, actually, no, wait, we're going about this wrong. There always needs to be, this always needs to happen. Okay, except that if the thing doesn't fit in the register. Is that true? Or is that just this ABI? Because we could easily have it where we encounter a parameter, it doesn't fit in a register, we omit the allocate store here. These can be omitted when they need to be right here. Sorry, it says, wait, you're confusing me now. Hold on. I'll just start talking about philosophy. How's it going, Hells? What's going on? Thank you so much for tuning in. Sorry, it says, I need to think about this. Give me a minute. No problem. No rushes. I can start thinking about other things. Another thing I wanted to, it's clear why we're doing this in cogen function, right? It's clear that, okay, I don't know if we need to do it here, but it does make sense that it would happen here, that when we emit a function, we would emit copies of the parameters locally. But that doesn't need to happen. That's kind of a ABI specific thing. It can happen in intercept in itself, but the problem is that there's no easy way to undo it. We can't remove these. If these were easy to remove and it was like, oh yeah, just track down this L value we generated and this, which I guess we just need to track down this store and remove its operand and keep the parameter, right? So it says, why does this need to happen at all? Because we can alter parameters as local variables. And so it says it does, just making sure that's clear. Yeah. Basically, we need to have parameters act as local variables, which means we need to be able to change their values and access them at different times, which means that we need to treat them as local variables. Local variables are code-genned in a way that we actually allocate them on the stack, right? So local variables go on the stack, which means that we need to have these on the stack. And in order to use the registers that the parameters are passed in, we need to save them as quick as possible onto the stack in memory. That way we can start using the registers for other things. Hells151 says, I'm pretty new here and not really familiar with C or C++, but it looks interesting. Nice. It's definitely not the best C or C++. I'm just, but it's, you know, I'm making a project and it's coming along. So it says, yeah, so basically we need to provide storage for them. Exactly. But in certain ABIs, the storage is provided by the caller and not the callee. Now, if the param is e.g. in an SDL event, then the caller has already provided storage for them. In certain ABIs. That's backend specific, I feel like. Or it's ABI specific, and should we just do this here and handle the ABI? So instead of making a local copy and setting the alloc as the address of the parameter, we need to just do nothing. Yeah. We need to take the pointer that's passed in and treat that as the address. Yeah. Pass it through. Which I think is easy, right? Because it's basically just the address of this thing. And then the store. Where's this store actually used? Is an interesting thing. It's not used, it's just its side effect is taken advantage of, that we have now stored the thing. Okay. Because the problem is if we're emitting like LLVMIR, I don't think we need to worry about any of this. But we still do need to worry about this because we don't want to emit this stuff. So it says, okay, this is a bit cursed, but basically, oh, I'm ready for this one. Could you set the parameter value as the address of the decal here? Instead of calling cogent L value, because this is what emits the alloc. I mean, we don't want to do any of this. None of this needs to happen. Only for params that don't fit in registers, of course. Yeah. But none of this needs to happen. We don't need the store, because we don't want to store into itself. That wouldn't make any sense. So we just need to not do this. So it says incorrect. We do need to set the address of the local. Well, yeah, we need to set this address. We don't, you're right, we need to pass it through. But I'm saying conventionally, none of this needs to happen. What needs to happen is like this, right? We just need to say address equals question mark. This would be P, right? The IR parameter. None of this needs to happen, but instead something else needs to happen, if you will. Yeah, sorta. we don't actually need to do anything. We just need to point fingers around and say, you point to you, and we're good. So we're not technically doing anything, but yes, we need to do something else. There isn't nothing here. So it says, yeah, I think that's right. Okay. Now, here's the question. The $1 million question. What's the if? What separates these two things? Because I have no clue. It doesn't seem like it's a good thing. Just adding a type fits in register or something callback is a good thing to have anyway, because other parts of the compiler might need that too. Do we know what types fit in registers in the backend before we've been passed all the type data? Do we just use type size of? Other parts of the compiler might need that too. It should be parameter is in register or whatever. Yeah, but I don't think that stuff is initialized yet. You know what I mean? Let's check it out. Whoops. So, it's like I'm in Parliament. What am I doing? So if we added some API or whatever, if you have 60 params, they're going to be on the stack no matter whether they fit in a register or not. Right? Hells 151. I am curious if your compiler is a personal project or if you aspire to elevate it to a more professional level. Well, personally, I feel professional. So let's go with both. So it says, and yes, you do know the types because they're part of the function signature. So what you're saying is parameter is in register should just take in a function. Hells 151 says, oh, okay, I see. I was just messing with you, by the way, Hells. Everything I say up here I'm an E-clown. You gotta take that into consideration. So then we just need like a index, right? Parameter index. And then we just say some stuff. So it says a function and a parameter index, maybe, yeah. Legendary. So let's say this is what it is. What data do we need? Because don't we, in CodeGen emit, don't we initialize like our argument registers? Am I crazy? Where do we do our argument register initialization? We do it during lowering. Where was I? Oh, it's right here. Hilarious. Okay. That means that until we lower, we can't call this because we don't know. Not mean, Saraid? It kind of feels messy there. This isn't going to go well. Do you see what I mean? Like we don't know until we actually get here. Because we have to do stuff. I'm just saying it seems like it's in the wrong order. So it says, I don't know if this works at the compiler at this point in time. But what I'm saying is what we should do. That's fine. I made up that next part, by the way, because you left me at, but what I'm saying is, and my brain had to fill in something. Saraid's saying something. But if this is how it's the information provided by Semo when emitting a function is sufficient to determine whether or not a parameter will be in a register. Is it? Well, that mean we would also need a CodeGen context and then just do this, right? Is that what you're saying? Oh, just pass the context. Do this. That's hard. And then we just need to say basically if function. We should also ice if parameter index is greater than or equal to function type wet function type function parameters size. Wonderful. Parameter index out of bounds. An IR function should contain a reference to the context. That's fine. We'll just pass it anyway. We do this stupid stuff no matter what. And then we should probably move it to a function. It really doesn't matter. Assign arg, call conv arg registers. It doesn't matter to me. We need a context. This thing. Beautiful. What? All of that should probably happen when the context is created, setting the argregs, etc. When is the context created then? I mean, I'm all for it. Let's do this in one spot, not a million. What do we do? Might be also we don't need this context then. This funky thing. Oh, we still need it. Context. Somewhere here? No? Where do we create this fucker? Lots of emits. Here we go. Jesus. Okay. I don't think any of this is used anymore. To be fully honest. And then we need to move all this stuff. All this stuff. How beautiful. Sure. You kidding me? It's used right here. So annoying. So it's not set yet. We basically set it here. So we can not do this. We can just have these. We already know the calling convention. Beautiful stuff. And these can go in the Linux one. Beautiful stuff. Okay, that's a mess. Lens, you're being blind again, line 753. You need to allocate it before setting values in it. Listen, it was a copy-paste error. It's not my fault. I mean, I copy and pasted, but let's not get into semantics. So we've set things. Okay. So now that happens when the cogen context is created. We never have to worry about that not happening if we have a cogen context. So as long as we pass one into this function, we're good. Which means that now we need to say switch on the thing. Calling convention, blah, or whatever. I don't know what it'll be. What is it? This is going to be context call convention. call conv mswin break. What are we doing? If parameter index is greater than or equal to 4, return true. If function, okay, we should probably get parameter as a thing. This has to be in bounds. Oh boy. Parameter type. The size of that is greater than 8. This is a mess. Return true, I guess, as well. Also, these are backwards. That's fantastic. Return false. Otherwise, return true. Sure. And then for all sys5, so I'm not even gonna, I don't want to touch on this for now. It's so much. It's like a recursive algorithm we're gonna have to figure out. I don't even want to think about it. Not yet support determining sys5 ABI specifics for parameters. Sorry. What a mess. Is there official documentation about your project? I like the syntax, etc. There's plenty of examples. If you want to check out the examples, there's documentation on the compiler itself. There's a reference that I wrote like probably 6 months ago at this point. But there is like docs, there are PDFs that you can check out if you would like. These things, which definitely goes into a lot of it, but it's missing a lot as well because things have changed. But it has a lot of the main basics, I'd say. And it's not finished. It's old. If you just look at the examples, really. You can check out linking with SDL and how this works. You can check out something basic like Fibonacci. And you can ask any questions in the Discord here on live on Twitch. Anything like that. Nice. Expected expression before nothing token. What have I done? Where did I do that? Codegen.c 709. Ah, yes, that'll definitely cause some issues. What's the function? What function are we in? Emit a function. Context function. No, so maybe we can just use context function. Okay, now we have to go write this. Parameter is in register. It's exactly like this. Jesus. This is going to be a Boolean return value with an IR function pointer function parameter index and a codegen context pointer context. Beautiful stuff. Now we just need to switch on not the format, but the interesting The call convention, this thing. And the call convention is actually the context call convention. There it is. And we can actually, let's just do a switch, clean everything up here. Doesn't really matter. Jesus. Okay, that didn't work. And yeah, we're not going to be doing this crazy stuff. I don't know why I kept those. We're basically going to be doing... This is based on the back end. So this isn't going to be based on the call convention, I don't think. It is in the back end, but in the actual... Why do I not have... There we go. Is this going to be format? I guess it might be format. It might be a switch on format. It probably will be. Yeah, I don't know why I was crazy thinking it was the other stuff. Unrecognized format in... Yeah. The language is this compiler for? I'm sure you're asking what language. It's for intercept. I didn't really have a plan, but I went ahead and started making this compiler from scratch in C anyways. I made it up. You can go back and look at the first video, the first stream, the VOD of it. And I basically just, I basically just made it up in the first 15 minutes. And it has evolved from there, obviously. I didn't know the future and think of everything, but that's just kind of, that's it. There's not really anything more complicated to it than that. So this is the wrong switch. Default ICE unrecognized format. It's going to be return true, return false. Probably just unreachable. Then we're going to say what? Yeah, nothing like this. Nothing like this. We're just going to return. I guess I don't even need anything. We're just going to return. Parameter is in register. This is going to be in, or have to be in, CodeGen x86-64. And this is going to be function point function. Do we have integers? What is it in this code base? What are the types? The usize and stuff. I don't care. I'll just put size D. Parameter is in register x86-64. Context function. Parameter index. Whoa, parameter index. Why are you mad? Did I say it returns void? Ah, silly me. Ah, silly me. It's not ideal. It's fine though. Still builds? No, it does not. Context undeclared. Right. If parameter is in register context. Oh, it's CTX. Okie doke. Didn't work. It didn't work. How long have you been programming, if you don't mind me asking? I don't mind you asking anything. We like questions around here. I like your name, by the way. How long have you been programming? Like it a year and a half, 2 years. Depends on who you ask, I guess. I programmed a long time ago, but I didn't like do a lot or understand what I was doing. I just followed tutorials. But it's like where I actually started to understand things and do it myself is a year or two ago. I don't know, something like that. If parameter, I see. Have I done this backwards? If parameter is in register, so what does that actually return? Parameter is in register. It returns, parameter is in register x86-64. And what does that return? I just wrote it. I know I should know, but it returns true unless the parameter is or the type size is greater than 8. Hmm. 1 year and then doing low-level compiler stuff is impressive. TNT Master says, questions make the place more livelier. Exactly. Stuff happens. Especially doing everything in C. Well, it's not the right way to do things. It's just a way to do things. So we should be returning false for certain things. Why isn't this working? First of all, these are backwards. Let's think about this. Okay, that's what it was. I just had them backwards. That's hilarious. So now, did that just work? I think that might have just worked. Also, hold on. I want to do another thing, which is that the L value of a member access, we're going to say basically 0 offset doesn't need an add. Yeah? So we're going to say if L value, so this is, the L value is the member access itself. And we have a member access struct, identifier, and member. If the member byte offset is equal to 0, it's not equal 0. Well, if it's equal to 0, we have to do something else. So this. I'm just curious if we can get away with a little optimization here. What have I done? I've broken things. Cannot emit IR load from type SDL event as it is not a pointer. Okay, I didn't set the type. That's fine. Hey, 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 hey. So with this SDL event type now, this thing, did we not get there? Where do we get to? Passing arguments on the stack. For SDL create window. Didn't we already do this? Am I crazy? What did I just do? Right? So I'm just curious now. If I change this, does this have anything to do with anything? This was the one. So if 0 and, because that'll never happen. 0 and anything is false. Passing struct array arguments. So we don't yet support passing struct array arguments. And we get to the point where we actually lower the call to SDL event type and the call to SDL create window. Me changing that apparently affected a lot. So I'm not gonna worry about that yet. We'll do that optimization later. I'll just add a fix me or a to do. Zero literal when member has 0. Oh, we just weren't setting the type. Okay, that makes sense now. To the first member. When member has 0 byte offset, we can just use the address of the struct with a modified type. I think that's the problem, is that we were modifying the type of the L value, the address type. But when we were saying L value address is just equal to another thing, then we were modifying that type. We're getting type errors. It makes more sense now. Struct array arguments. Doesn't yet support passing struct. Where are we actually hitting this? 16, 17. Okay. So here, that's right. For every use of this parameter, we need to add a dereference, right? I don't know if that's actually true because we would treat it as a local variable anyway, which has an alloc as its type. So when we add 110 here, we actually need the pointer to SDL event. So what is this? Stored in 9. An integer, okay. 0 extend. So we're 0 extending a byte into an integer. Okay. Okie doke. So we have hopefully lowered things properly. We've unrolled a mem copy at compile time. That's pog. And we just need so if we don't need to do this, then we do. Is this it? Okay. And then we say what? We're probably getting here. Do we have to do anything here? I don't think we have to do anything. At all. Right? I think this is just we have to say if the parameter index is less than the argument register count, do this stuff. Otherwise, you don't have to do anything. Leave it be. Call it good. Does this make any sense? We're going to see. Handle stack allocated function parameters somehow. Legendary. In register allocation. Okay. Well, we're making it further. We don't have to do anything. Right? I don't think we have to do anything. Is that a possibility? What are we doing? Function call arguments. We get the argument instruction. We get its result. We copy it into the result. Don't do that unless... Here, you know what? We don't even need to change it that much. Because this means we're at the end. We can just break. Unreachable. 1710. Mangle type 2. We have type primitive, named, pointer, array, function. We don't have struct. Why are we trying to mangle type 2 of struct? First of all, Sraid. So we mangle function names, which means that the function return type gets mangled. Sraid says, How do we mangle structs? Yeah, this is where we're at. This is, I think I've done everything. We have SDL create window, stack past parameters. We have no copy. We're just using the SDL event pointer. I'm currently implementing something that inherits from standard variant, so I'm not listening that actively. Just the struct name, I'd say. That's so cursed. Okay. If there is no struct name, just make one. Naturally. How do we know its name? I don't think we even know its name. Otherwise, it'd be a named type. Do I literally just make it up? As in number of characters plus name. Yeah. The decal should have the name. I see. Oh yeah, beautiful. Beautiful stuff. So we're just doing the name. I think I can just do that. Okay. Tired Beaver, what is your day job? That's a good question. Sorry, the decal should... Oh, I already read that. Format 2. Else. Don't even really need these. Buffer. Yeah, don't do data. Percentage %s is the entire string. That's right. Otherwise, what do I do? Do I just like use a static here? Do I kind of just go hacky and say static struct count? Is this not okay? I feel like this is not okay. We'd have to figure out the... Yeah, sure, something like that. Oh god. So, how do we figure out the width? The width of a number. We could use like snprintf with null and 0. That feels like overkill. If anyone relies on anonymous structs having fixed names, then that's their fault anyway. It's true. Sprite says, don't do that. I'm pretty sure we have a number width somewhere. We do! Legendary. I didn't know that existed. That's probably not how things should happen. That'll make more sense. Legendary, legendary, legendary. Okay, so if it has a name, use the name. Otherwise, make up some name for their struct. It's just numbers. It's not really ideal, but... Dun dun. Uh-oh. Guys, it worked. That's the scariest time. Okay. We have proper globals. Ah, we need it for the parameter. Okay. We have our string literals. STL init. Well, this would be cool if this works. I can't imagine it's going to work, and I'm going to need to test something simpler. But here we go. Okay. It actually worked. Okay, it got far enough to linking is what I'm surprised about. It compiled. So, of course, I would love to just do that. And it says cannot find LSDL2. So where is SDL2 on my machine? SDL, what is it? 2. Am I freaking out? Okay, 2 dot. So let's say it's this thing. Is that correct? Is it this thing plus lib? Something happened. Hey. Oh. Tired Beaver says, I'm still quite shocked at your projects on GitHub, considering you've only been coding for a year. I'm in shock, flabbergasted. Thank you. I appreciate that. Sorry, I mean, it's been over a year. I think Lenser OS is over a year old at this point. It's been like 2 years closer at this point. Time goes by so fast during the pandemic. Sorry, it says Windows moment. Let's watch Lenser spend more time trying to link against SDL2 than writing this entire feature because Windows. I mean, we did it right away. Tired Beaver says, how long did it take you to learn assembly? I'm still learning it, but it's the basics of it, not long. Look up a von Neumann architecture and learn how that works, and then assembly makes a lot of sense. Learning stack-based machines and programming languages helped me a lot with assembly and understanding how actual computing can get done, arbitrary computing. We did it. Let's make some simpler examples that aren't SDL, you know what I mean? Because I could just be screwing up SDL calls. We get to write tests. And what do we want to write? We want to write function arguments many. Let's do a function with 8 arguments and it sums them all up or something. So we have sum8, which will return an integer and take in a whole bunch of integers. A, B, C, D, F, G, H. 1, 2, 3, 4. Ah, that's ugly. What's 34? 17. 17's prime, isn't it? So we can have 17, 17. 10, 7. 10, 7. There's 6, right? So then 1, 0. Let's do 0, 1. So this should ideally return 69. Oh, I'm such a child. Wonderful. Cannot emit IR load from type integer as it is not a pointer. What a beautiful AST. What? Mr. Mugume 000000069. Oh god, that AST. It's beautiful. Cannot emit IR load from type integer param5 integer. I feel like that's something I just changed. What are we doing? Cannot emit load from type integer param5 integer. You can't emit a load from an integer? That doesn't sound right. Where is this happening from? I don't really know because I don't have a stack trace. I can guess. Let's go through and guess. Well, there's an exact cannot emit IR load. So does it have to do with here? Just curious. Yeah, it doesn't help, Sir. I appreciate it. It doesn't really help me at all. We can go exactly to where IR load is defined. Cool, Sir. Line 521 of intermediate representation.c. It'll help so much to see IR load implementation. We need to figure out where it's called from. There's no stack trace. That's it. The line number doesn't do anything. We never made it to there. And we can see it's the same one. So we're loading from an integer, param5. Param5 should be lowered. When is this happening? So we're trying to emit an L value, which is a var reference. The var ref is to an integer parameter, which before happened to be an alloc, but now when we no longer where did that if go? Am I crazy? That's in here, right? What is it called? Parameter is in register. This is the problem. This is not the proper type now. Because if it's not in a register, it's in memory. That means it's a pointer. This is a mess, and it's going to break everything. Unlowered parameter instruction in register allocator. What? What are you talking about? Unlowered parameter instruction in register allocator. What does that even mean? Needs register was called on an IR parameter. Basically, the RI can't handle parameter instructions. Should we change these to allocays? Would that help? It's not really going to help. Like, these are just supposed to be pointers. They're not anything. They have to be lowered to IR register instructions, etc. first. Where? So you're saying in the x86-64 backend, there's a pass that already does that somewhere. This thing? So you're saying I have to do this no matter what, even though it doesn't make any sense. Well, okay. What an IR spectacle. This is a little worrying. Oh, okay. Yeah, that needs to be turned into an RBP relative load, I think. What does? Yeah. Yeah, it's going to be a mess. I don't think it's being code-gen properly, like you said. What are we doing? I don't need to do anything. Just meant to return 69. And it returns big problems. So let's look at the code, because now we're actually at code-gen, I believe. We can load a bunch of immediates. That looks fine. I don't know why we necessarily do this, but we do this. We allocate 8 RBX. So this is 8 off the base pointer because we've sub 72. What? Sword says the IR parameter needs to be lowered to, in this case, the address of the copy of the local on the stack. A frog and a log and a bog. So we start storing into the reversed order onto the stack. Everything looks fine here, I'd say. We push some things. We sub some things. Okay, that's a little confusing. We get our return value out in racks. So it looks like the problem is in here. This is fine. So we store the first 4 on the stack. But when we load... So I'm interested what happens with 17. That's an interesting one. Also that function name, lol. Integer, 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 integer. But what's the problem with this? R9 hasn't been touched. Why is R9 being used here? What are these? So it says, do you know what the problem here is? No. That's why I'm trying to figure it out. We somehow need to compute that address in the callee. Right, we need to go upwards off of the base pointer. But how do we know? So how do we know when to do that? Is it in code gen of a call when we do all this register nonsense and like this? Is it in here? I hope it's not. It's not in here, right? Basically, IR parameter is the parameter value. Yes. We're lowering that to an IR register. For things that are passed in registers, that's the value. For things that are passed in memory, that's the pointer. Yes. So the call already has things set up because it's lowered properly, so everything should be fine as far as this. Which means that it's actually the use of the lowered okay. It's actually the use of the lowered argument, right? Not argument. We have the parameter. Aaliyah off the RBP. How do we normally code gen Aaliyah off of RBP? I mean, changed since last saved. What the fuck you on about? Normally we use IR allocate for that. We might have to do this after RA and simply, what do you mean? What could we do after RA? Copying the copy wouldn't implement the ABI, but it would. Well, it sort of would. Because this is only in R functions. We could try and somehow encode that in IR, but I'm not sure which one would be easier. So if we say IR parameter does need register, why would we do that? Why would we do that? Because then we're going to register allocate a whole bunch of registers that we don't need. And the uses are going to be all off in the live ranges. Maybe generate and add the adds register base pointer plus immediate stack offset. Okay. So for a parameter, and whose type is a pointer to the thing on the stack, the key part of all of that. So when we actually lower a type to a pointer, which may happen here or if it's greater than the register count. Oh boy. Okay. So we need to replace IR parameter as far as we're concerned. Yeah? Also, that check for less than argument register count is also incorrect. Cool. How do we fix it? The left-hand side is going to be an IR register. I guess I can do this. I don't have like register, do I? I have result. Maybe that's what I just set. Yeah, just like here. So we add RBP. And then we add the stack offset of this IR parameter. Which is going to have to do with the parameter index, which we're going to need to save. So it says because if the first parameter is a struct, then it might not go in a register. It won't go in a register. What do you mean? IRC and sys5, you just do all of this nonsense if it goes on the stack and then allocate the next one or whatever you encounter parameter that does fit in a register. I'm not sure if MSWin does the same thing or if only the first parameters are. Yeah, your last comment is spot on the money. MSWin just has 4 registers that go in 4 parameters that go in registers, and the rest is nothing. We just care about the first 4. But what you're saying is this is all different. So we need to have an if fucking context call convention here too, right? We need to say, hey, if you're on sys5, else if this is true, do that. Really, I should put this in a thing. This is horrible. Backend does not yet support sys5 any fucking thing because it's complicated. So it says also. Also. What am I doing? So we're gonna need to go reverse for each. Why? What? That's not true, though. That's not how that works. You're just suggesting things that would not follow the MSWin ABI. We didn't just write it for no reason, I promise. The instruction is a parameter. So we need to figure out which parameter we are effectively. Yeah, I think the logic here is a bit off. Maybe I'm wrong. Maybe. I'm sure it's a bit off too. I don't think it's perfect. Sorry, yep, that's accurate. Anything that's not accurate, anything that is less than 8 bytes. No, anything that is 8 bytes or less gets passed in a register if it's one of the first 4 params. That's not even really true. That's not how that works. Because C arrays wouldn't. In our case, yes, anything 8 bytes or less gets passed in a register if it's one of the first 4. If it's not one of the first 4, it goes on the stack in reverse order, no matter what it is. And if it's one of the first 4 and greater than 8 bytes, and it goes on the stack, which is what this currently does, as far as I know. So we have an instruction, which is in a function. Well, it's in a block. Sure. Which is in a function. Then shouldn't we just check for the size and not care about whether it's a type struct, etc.? Well, nothing else can be... What do you mean? Nothing else can be a different size. An integer is 8 bytes. A byte is 1 byte. If we do bools or I32, blah, 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 it's all 8 bytes or less. So the only things that can be larger than 8 bytes are structs or arrays. Why are we checking the size inside of that first if then? What? Which if? (1606). Okay, it's first if, it's an else if. We're checking the type here because structs that are smaller than 8 bytes or smaller, they're not greater than 8 bytes, then you just pass them as a register, right? You make it down here and it becomes, it's passed in a register if possible. Otherwise, it'll just be, passed on the stack. So we might need to check that. I mean, I don't know. Do we need to check anything? We just lower it either way. Should this be type size of greater than 8 or index is greater than argument register count? Why are you mad? Function isn't a thing. So this is for each param in reverse. What is this? -1. Then we're going to say if basically if I is equal to parameter index then it means we have successfully reached this parameter and we can break. Otherwise, base pointer offset needs to be added the type size of param type. But yeah. Sorry, it says, yeah, cool. If you want to refactor it in a way that doesn't change the semantics of the program, that'd be sweet. If it could be simpler. I don't think this is good code or this is the right way to do things. I'm just getting it working. For each putter reverse. So this is how much up from the base pointer we're going to need to be to access this thing. I don't know if this makes any sense. Can probably do this. So we add offset to the RBP and make it a pointer to the thing. Coolio. So the only thing I think we could do is like make the Linux thing at the top, right? It's just, it's messy no matter what, because this is a mess. I would fully agree with you, Saray, that this is not easy to understand or the right way to do things. Pretty much guaranteed. But I made it, so what can you expect? Where'd it go? The call convention. So we have MSWin and Linux. So we can do the first four in Linux, where we basically just said type size of, what is it, instruction type is greater than 8, or instruction immediate is greater than or equal to argument register count. To do x86-64 backend does not yet support passing complex parameters with sys5 ABI. Sorry, working on it. Else, we just did what we did before, right? This is kind of what we did for all of them. Argument registers has to be in bounds. And we're good here. Coolio. And then we can also add here if instruction type kind is equal to type struct, because we don't handle that at all, right? Or an array. It's a mess, but I think that's more accurate as far as things go. What if we did like that? That's so ugly. I don't know. I don't like it either way. Sure, we'll go with that. For Microsoft Windows, we need, first of all, to get type canonical. And then we're going to say we don't need to do this anymore. What if we just have, we see we don't need to do this. All we have to say is if type size of type is greater than 8. Lower type to a pointer, because that's how calls have been altered as well. Coolio. What else do we have? Then we say this thing. Yeah. So this is probably wrong, but we'll think about it for now. We remove these. Are you feeling better about that, Saray? I don't think we need this either. What did I just do? There we go. Soraid says, yeah, that looks better. Alrighty, Soraid's happy. We've done it. It crashes horribly. No, it says unload parameter instruction and register allocator. So this has to do, these instructions are being actually used by the register allocator because 5 is used here. Kind of hacky. But if we emitted a copy, we don't really want to emit a copy. What do we want to emit? What's happening here? That still doesn't handle all cases, but it's better because the 2 cases are greater than 8 bytes or not in the first 4 params and less than or 8 bytes in the first 4 params. So what are you talking about? If type size of is greater than 8, then we have to do this. Else, we have to do this. Is this what you're saying? Does that help you? There are now 2 paths. I guess we also now have to say if we want to do this part no matter what, if index is greater than thing. So argument register count. Yeah? Else do the IR register thing. Yeah. Okay. We've caused a seg fault, Saraid. You're evil. What have you done? Greater than or equal. I mean, it's still just seg faults. Doesn't matter. That's just my shell bugging out. By the way, it's not anything Saraid did, in case you didn't catch that. It's just because this code is now actually being used. What are we doing wrong here? Debugger time. No! Debugging's so stupid. Can't we just write code that works? Debugging's just annoying. It really is. It's just like you launch this fucking program that takes 8 gigabytes of memory and takes 10 minutes to do anything. It's so annoying. Or you can use GDB and it doesn't fucking work. I mean, it works. It just takes 10 minutes to even figure out what you're looking at. Like, finally I got a TUI up and running. That's definitely in your opinion, Saraid, because it's easier to just put prints everywhere and say here, right? But this one says there. Ooh. Then you see, which one did we make it to? None. They're not there. That's interesting, ain't it? So it must be before here. Do we make it here? And then you can move your there and go, oh, my there. We never reached here, right? So I can put that somewhere else now. It's not that bad. Look, we have now here and there. And then if we go here, do we have there? We don't. So look, it's in between these two. And what if I move here up? Do we still see here? We do. Do we still see here? We do. Do we still see here? We do. So it's in this loop. Somehow this loop is fucked. So my guess is that this isn't a thing. Whereas the debugger would just tell you it's here. Sorta. I mean, this is a giant program. There's like 10,000 lines of code. Yeah, Visual Studio just started. Sorry, it's trying to tell me you could have started VS. I did start VS in that time. I was waiting. Shaking my head. You've no faith in the man's. No faith. What just happened? Okay, yeah. I want to undo and redo C. This fucking stupid editor. Function arguments many.int? Is that what it was? We're just going to test. We already know where it is. But let's see the magical debugger and how powerful it is. In the time it took VS to start, I already figured out where it was. Yep. Cool. Do you want to stop debugging? Sure. This is so stupid. I pressed the play button. Where will it take me? Oh man, type size of is null. In lower. Oh man, param type null. Coolio. Now we know. Why is param type null? That's really not good. So we have a bunch of parameters and it just doesn't have a type. No, there is not, Mr. Mugame. Poolard Twitch, what's going on? Why do we have type size of is null? Am I looping over the wrong thing? What is parameters? Ah. That'll definitely be an issue. It's not an IR instruction pointer. It's a parameter. Did I write for each reverse? I might not have written for each reverse. Why are you so mad? Okay, Jesus Christ. Data plus vector dot size minus 1. Element is greater than or equal to data minus element. Why are you so mad? Can you change your mind on that? Thank you. Okay. So param type. Is parameter a pointer still? I don't think it is. So why does it tell us to do a pointer? Because we have type pointer element. Is this right? Am I crazy? I'm surprised that there weren't any warnings about that. Did you not check the warnings? No warnings. I mean, there are warnings. Yeah, right here. It's a parameter pointer. Cool. So I need to use param type in that way. Things should be fine. Byte size cannot be converted into register size. 0. Well, what doesn't have a register allocated? Senior. They all have registers allocated. Not sure what you're talking about. Are we not setting the type? What are we not setting the type of? Offset is an immediate. Maybe that's, we're not setting the type of offset. Whoa, what just happened? What just happened? So I'm doing open line and it's just pasting a bunch of stuff. I don't know what's going on there. I'm trying to just make a new line like that, but it's doing that. Okay. Could not find register with descriptor of 0. Okay. Copy 0. Oh, we're not inserting these things. God damn it. Okay, that's happening again. That's really annoying. Poolar Twitch says, I love how chat is displayed, XD. I'm glad you like it. I'm glad you like it. We need to insert the instruction before this instruction. I did that one crazy. Jeez. Sure. Am I insane? Does this make no sense? What's happening here? We have the 4 registers, which makes sense. And then we have a lot of extra weird stuff. Why are we getting register type? Sorry, it says BRB. Right when we need them the most. No! Mr. Mugame says we need coloring in the chat, or is this too hard to add? Is the name color sent over IRC? I mean, IRC doesn't support colors, so no, it's not. Poolar Twitch, are you doing a compiler? Thanks for following, Poolar Twitch. Yep, that's what's happening right now. So we insert these 2 things. What is happening? So this is RBP. Okay. That's what Suraid was saying. This is RBP. So we load RBP. We copy it. That's fine. We load the immediate. Why is this copy generated? and then not used. What? Left-hand side is RBP. So instruction left-hand side is RBP. This thing. Then we insert. What is happening here? Does anybody know what's going on? This doesn't make a lot of sense to me. Then we insert the immediate. And somehow in between these two, there's an unused copy. There's a bunch of unused copies. I don't know what's going on. Don't worry about those. Byte size cannot be in a register size 0, so we have void. Do we need to set type integer on the higher register? Why is that happening? God, that's annoying. Oh my god. I'm gonna kill someone. What is this? What the fuck? No. Don't insert a fucking for each putter reverse every time. What the fuck are you talking about? Emacs, why? Yeah, it's gonna be fucking nil. Jesus. Okay, I can actually make new lines now. Jesus Christ. Oh, Emacs. Why? So is it because we didn't know? It is because we didn't know RBP was the size of an integer. Okay, now the real question becomes, how far off the base pointer is it actually? So that means we're gonna have to deal with all this stuff, right? This is so complex. I hate it. I hate it so much. So these allocays are pushed in reverse order on the stack, which means that this is all gonna break. It's not gonna work. It's as if we have to insert these allocays before the call itself. It's probably not ever going to be fixed. I don't know if we're going to even be able to use this code, Sarade. So we have to insert our allocays after these. Little issue there. These are emitted as part of the call. All of these, this is the call, as you can see by the number 17 above it. There's just one call that generates all of this. You see an issue? You see an issue, Sarade? About the stack? We have to insert these allocays. Like these pushes and these pops are going to break everything. Because when we call this, it's expecting shit on the fucking stack. And it's going to get all this. And then all this. And that's not what we need. The username, color, and the badges are sent over IRC. You just have to subscribe to the extra metadata. What format is the extra metadata in? I don't think IRC supports color. So I'm confused at what you're saying there. It may be available. That doesn't mean like an IRC client will be able to view it, right? Is it like MIRC colors? But yeah, I don't think Serrate I'm gonna be able to do anything. I think it's just gonna go unused. Mr. Mugame says, "Oh, it's not your own IRC client." Nope, it's ERC. It's a part of Emacs, my text editor. I suppose the params have to be passed after saving restoring registers. Sounds easy, doesn't it? Well, you're wrong. Just change how everything works. That'll be easy. So we just can't do this anymore here. That's simple. And extra alignment has to happen before that, probably. I don't know about that. Just all this stupid bullshit can't happen here. Basically, we're fucked. I implemented half of it, but it's not going to help us at all, and the code isn't really usable. So, I mean, I guess we could test if, like, things break. Did I break everything? Or did I just make shit that doesn't work? Looks like I just made shit that doesn't work, because everything still works. Just the same tests failed. Which is a little worrying, because there's a test in here that I added, isn't there? Did that work right at all? Isn't there another one that should be failing? The fucking... Function arguments many? This one's just pretending to pass. Excuse me. I don't have to like add this, right? It's a glob. Interesting. I don't know. I don't know what's going on. Nothing works. I made it, so it makes sense. Well, I didn't break everything. I just made stuff that doesn't work. There's function arguments many. That's failing. I don't know why C-test thought, yeah, it's not failing. It's fine. What is C-test on about? I've got to know. Do we see function? Could probably just search for it. Is it just not running it? Interesting. So C-test seems to not catch the new things. So the glob doesn't actually capture everything. So we'd have to do like a... I'd have to rerun CMake, that's all. Well, I guess I'll commit everything I have to a branch. I mean, it's probably not going to be used. Oh, we'll commit this. We can commit for each reverse. That's fine. That'll be useful. For each reverse macro for vectors. CMake globs are a bit scuffed IRC. Yeah, it's just when it happens. We're configure time versus build time. I want it to happen at build time, but it happens at configure time, which is annoying. And then we're just gonna do new branch based on main, that is. What should I call this? Name for new branch is going to be complex params. Parameter is in register API. I don't know if I'm going to be able to separate this. Excuse me? Where is it implemented? Here. Okay, I'm looking right at it. I'm just not smart. But this has to know the... Okay. Yeah, I'm just going to do this all at once. I don't care about splitting this up into commits. We're just going to say, make a mess. Code gen. We made a horrible mess. We're halfway there, but the half we didn't do is like 150% of the work of the half we did do. Basically, the stack is used to save, restore color saved registers. Right? Yeah. But that gets in the way of passing parameters on the stack. What do you know? What do you know? Beautiful stuff. You can now look at this horrible code yourself on GitHub. It's live on origin/complex params. So, by the way, I should be able to do this. Yeah, I don't need to do that. Hold on. A lot less printout. And hopefully that new function one will be caught now. And it'll print some stuff. There it is, function arguments many. With a crazy return status. And it looks like we were able to compile it, but the actual test returned the wrong code. Which makes sense. So yeah, I don't think this is gonna go well. Because just have to change how everything works and has worked for a long time, so that's fun. Yeah, this doesn't matter, can't happen here anymore. Can't happen, yeah. This is annoying. I don't really have a solution. I'm trying to think. I've got no solution to this. Because we just can't do any of this here. But I don't know where we can do this then. Because we have to emit a bunch of pushes. To save a bunch of caller saved registers. But we can't do that anymore. Because there's now like things on the stack that matter, what their offsets are from the call. So if we can't push these here, we have to push them before. But if we push them before, they're not going to be saved. They're going to be overwritten. So I've got no solution there. You have any idea, Saraid, what the solution to this is? I've got no solution. Nothing coming to mind, at least. It's like, oh yeah, just do it somewhere else, but I don't know how to do that. Because then the registers aren't going to be saved or restored at the right time. What's the ABI say? Like, where are we actually supposed to put these fucking caller saved registers? That's all it fucking okay. That's it. It doesn't say anything. Save them magically. It doesn't even say save them. It doesn't. It says consider volatile registers destroyed on function calls unless otherwise safety provable by analysis. Look at what Clang spits out. For what? Isn't it going to be really complicated to get its register allocator to like actually save and restore a register? What can I do here? I guess I'll just do the same stupid shit. See the E, F, G, H. Fuck. I'd usually make that an extern function. Push 7? So it pushes these two things. Moves a bunch of things into registers. Doesn't save anything. See what I'm mentioning here? We can't get it to save a register past. Like, we're gonna have to do some bullshit like this. Like, can you now save Z as a register? Nope, it just does it in there. So, like, do we have to do register? No? Nothing like that? Just saying, we can't, it doesn't help us. Can't actually see anything that it's doing. Can go trunk clang. Yep, no register. They just store it in memory. 01, do you store things in registers then? Nope, you just return 69. How beautiful. Yeah, I've really got no solution. I may just be an idiot. I may, like, it pops into my head tomorrow and I go, oh, I was being dumb. Couldn't think of anything. It seems like a really complicated, stupid fucking problem. Because these stupid fucking, how do we save and restore registers on the stack? We have to control what's on the fucking stack. And then we have to use registers to to do this. It's like we have to save and restore these registers. I don't know. Let's say we move this before all the argument stuff. Magically. How do we do that? How do we do that? Before all the argument stuff. Every time there's a call, what do we do? So we lower a call by doing this stuff, which inserts the allocations, which need to happen right next. So do we just need to do this first? And say, like, do this here? Push, right? But then how do we pop them? If we push them here and then we allocate a bunch of stuff, it doesn't matter because the allocations are all... We just have to set the stack pointer before the call. That'd be really hacky. Okay, we can't, can we? We can't, because then whatever's below the stack pointer will be pushed when we call. So we need to be at the bottom of the stack. We can't just fake it and say, oh, the RSP is actually burp-a-da-burr. I've got nothing. Because we're basically saying, oh yeah, you just can't push anything here anymore. Which if that's true, then it's, where does all this happen? Where do all the pops happen? How do we pop from a stack that we push to, and then there's other stuff there? We can't push and pop. It's basically, we just have to implement like explicit allocays for each of these stupid save and restores of the function. This. So instead of using push, we'd have to end up using like move. And we'd have to move it into the stack and just have like a local variable that refers to this register that we save and restore. But that's stupid, because that means there's going to be local variables, copies, for every function call, for every register. So annoying. I'm gonna have to go soon. I don't have time. I have no solution. I wrote a bunch of code today. I'm tired. I got nothing. How are you guys doing? What are you guys working on? Ugh. By the way, have you seen my OS? The craziness that is the latest PR. I feel like I've done everything in it. It's amazing. let's just list. Memory request page does not return zeroed memory. We were assuming it does. No wonder we were having trouble. That file system can now traverse paths properly, totally separate. Third, process struct growing larger means heap expansion happens often when allocating new ones. Having the heap expand in the window between a process being in the schedules process list with valid CO3 member and when it was allocated meant that the heap expansion wasn't mapped in that process's page map. I don't think it has anything to do with instruction selection, Sarid. I'm not saying instruction selection wouldn't make it easier to do what we need to do, but it wouldn't fix our problem at all. Alone. There still has to be a bunch of code that we just write. Because just the order we do things in. Neutrino says, I'm also working on a programming language. That's awesome. That's very awesome. We just can't do anything we do. That's it. We can't do any of this. Can't do pushing. We can't sub off the stack pointer. We can't do any of this. Not allowed. So, yeah, that'll be fun. Yeah, it just doesn't work. Just the whole way we were doing it before is wrong. And it was a hack. Because none of this is going to work. Which means I don't know how it's going to work at all. I really don't. If we can't save and restore registers, it's like, oh, cool. Guess we're fucked then. There's pretty much nothing we can do. To this code. Like, we can't just change, oh, move this up here. We can't, like, rewrite. It just can't be here. The easy solution if janky would just be to spill them. That wouldn't work. Right? Where would we spill them? Sarade, where would we spill them? If you say on the stack, we can't. The stack has to have the parameters on it. So we'd have to like have some magical place on the stack before everything else. It's like, oh yeah, just go up on the stack and insert stuff there. It's like, we can't do that. It means that when lowering, before we do any of this, all the registers have to be saved. And then they magically have to be restored at some point after the call. But I don't know how, because how do we know where they are? It's just stupid. It's magical. I don't think it's going to work. What do they, like, what does GCC do? Oh yeah, they just don't fucking save registers. Because everything they're doing is so fucking complicated. They can't explain it anyway. So, we've basically got no choice. That's all I keep thinking of in my head. Like, well, you can't do anything to fix this. It's just a fundamental problem of how it was built. Yeah, I've got no solution. If anyone has anything, let me know. Neutrino says major refactor incoming. Ooh. No, there's not. I don't have any motivation to do that. I barely have motivation to do this. This takes a lot for me to do, because this is all stupid stuff that should just, in my opinion, just work. It's like, why do we need to not be able to store a register? Oh yeah, we just can't save or store registers. That's fun. Has nothing to do with the MSWin calling convention. What with the shadow stack? Well, then fix it for Unix. That's not, you can't just say, I don't know anything about Windows and I won't learn it. The thing we've been talking about for the last 3 hours and implementing, I know nothing about it and can't help. It makes me so mad. People just they reinforce their own opinions and they go, yeah, see, so that's why that happened. That's why I didn't know that, because it's Windows. Has nothing to do with, that's nothing to do with even what we're talking about. It's a problem with how things are emitted. It's just how calls are emitted. It has nothing to do with anything else. We can't set up the stack because the stack pointer is moved when we push registers to save them, or we pop them, and we can't do that anymore. Nothing to do with the shadow stack. So, I mean, what do you mean you can't help with this? It's okay if you can't help with this. I just think the reasoning of, oh, it's Microsoft is complicated, don't get it. Okay. Has nothing to do with that. There's no check for the Microsoft calling convention here, other than for the shadow stack, which you don't have to touch. It's just remove, like all this other shit. That's it. You just have to move it. You don't have to touch it. You just move it. All right? We don't need to change this code and change what it does. It just can't happen here. Or if we have to change this code, then that means just get rid of this. We don't need it. The only time we need it is because the minimum is that a function needs 32 bytes of shadow stack space above it, which is taken up by the parameters. So as soon as there's stack-based parameters, you just have to subtract their size from 32 until you go, oh, no more shadow stack needed. It is annoying, it's just not complicated, and it doesn't really have anything to do with solving the problem that we brought up, which is we can't push or pop caller saved registers, which have nothing to do with the specific calling convention. We're not saying we can't push or pop RCX and we need that for calling convention blah. We're just saying any caller saved register in any calling convention ever we're pushing, and we can't do that. That's all. That's my TED Talk. Neutrino says, I forgot to code loops into mine at some point. I feel you. Also, Surid, what do you mean by saner? What makes the MSWin ABI insane? It's just different, man. So tired of arguing this. Can we not just keep calling, oh, you're different, so it's stupid and I hate it? Like, can we stop doing that? I'm so tired of it. It's been fucking since elementary school. All idiots, they just go, oh, you're wearing a red shirt and you're supposed to wear a green shirt. It's like, okay, yeah. It's different. You're just gonna keep pointing it out endlessly? And you're like, cool. It doesn't help anybody. It's just annoying. And rude. Like, oh, you're different? Well, screw you. You suck. It's like, you could just, accept each other's differences and go, what is the difference? I guess it's not that big of a difference after all. Like, fucking 32 bytes of stack space. It's not a big difference. It's not hard to implement. If you keep just putting up your blocks and going, oh, I'm bad at math. I can't do 2 + 2. Well, no, you never will if you keep saying you're bad at math. Just fucking try. I know the sys5 ABI. It's not like my fucking Machine uses that. It's not like you're not able to learn two ABIs or know two things. That makes more sense, Sarade. I appreciate that. That's a real answer. Right, I also don't really have time to think about this in depth because I'm 4,000 lines deep into refactoring a web server. Very good reason. Totally valid, right? I could maybe help more if I was looking at this in more detail, which I'm not at the moment and don't have time to do so at the moment, okay? That's fine. That doesn't bother me. You don't have to help. What bothers me is when you say, I can't help because you're on Windows, so screw you. You go, I don't know enough about MS Win. If this was Sys5, oh man, maybe I could take a look at implementing that. But no, this is Windows, so nothing I can do. That's an excuse. It's just because you don't have time, okay? And I appreciate your answer. You don't have time. That's fine. You don't have to have time or make time for this stupid, silly project. Sorate says, I'm pretty sure that doing this shouldn't be this complicated because the general principle is fairly simple, but I don't have time to think about implementation details. I mean, I wouldn't say it's simple. You may think it's simple. It's not simple for me. How do we move all this stuff? We just can't do any of this anymore when we're emitting a call. So it's like, oh, cool. You know all that stuff you relied on before? Yeah, you just can't do that. It's really annoying. So what do we do now? We have to just magically know where to put things and restore things from. It's really fucking dumb. And we can't get a fucking example from a real compiler because they're all just so goddamn optimizing even at 0. It's like, oh yeah, you can't actually figure out. You just store everything on the stack. No need to actually ever, show the basic code generation. Just make it faster. It's just stupid because they could pass. It's like, do we need to do 03? Oh wait, no, because then it just does stupid fucking constant evaluation, which is so annoying. There's no control. We can't say, hey, please don't evaluate every fucking constant. All I want you to do is generate the code and stop changing it. They're like, yeah, we're just gonna, even at 0, we're just gonna load it into a thing. But there's no in between. It's not like there's no register saved past the function call ever. I don't really know how to make the compiler do that. So I can't even get a test of like, oh, this is how it's supposed to work. Because it doesn't ever matter. We can't get it to use something from before. It just stores it here and then is, cool. Nothing works. Well, I guess I'm just going to go soon. I've really got nothing else to write. None of the code I wrote today is ever going to be used. Probably just going to throw it away, go back to main, and pretend this never happened. Because it's not even fixable, I don't think. I really don't know how to fix it. Let's say, okay, we lower each register. Not here, but in IR call lowering, right? Instead of code generation, during lowering, we somehow omit all the pushes. Well, then we're not going to be able to pop. So there's no reason to use push. So then we just have to move into a stack address, which means that we're going to have to allocate and store into it, right? For every single saved function, we allocate and store into it. So stupid. And then that would be during lowering. But then what? So then the idea is that we'd have to insert the load from that saved space into the register. We'd have to do that after the call, also in lowering. This sounds horrible. So it's basically what we're saying is for that funcregs thing, we have to do that here. And then here's the stupid part. We have to know the size of all of the arguments that we're going to push on the stack, the total size, because we have to fucking align them. Because the stack has to be 16 byte aligned at the time of the call instruction. So we have to know all of these that we're going to do this to, and all of these that we're going to do this to, and we just have to magically add up that number. So that's fun. But yeah, then we generate a bunch of alloc stores. Then we just have to load from the alloc stores into each and every register. Seems like the most horrible way to do things. And even then, how do we keep track of the allocs? Like, we have to make a vector of fucking allocation instructions. This is horrible. This is not the right way to do things. Including racks? I don't even know. Ugh. This is so annoying. Because all this is so fucking complex and has to do with stack alignment and such bullshit fucking things. I don't want to deal with it again. You don't even have funcregs. Look at that shit. Okay. So we need to determine the total size of the pushed arguments below. That way we can insert an allocate here. The stack would be misaligned. That's kind of all we can have right now. Everything's going to be so broken. So we have a register to memory move, which is a move from, what is the source register? I. The full register. The address register See, here's the thing. We can't even do this. We have to omit IR here. So we have to say, like, fucking... caller saved reg. Here, I'm just going to call this S. What do I want to store? A register. So guess what? I got to make that instruction too. What a sound. We would like to store R into an allocate. Guess what? We got to make that too. Okay. The allocate is going to be 8 bytes. It's going to a pointer to an integer. Doesn't even matter what the source location is. It's just t integer. So before the call, we insert an allocate for the register, and then we insert a store into the allocate. We have to insert all these instructions ourselves. And mark uses. Everything is just going to be broken. It's not going to work for a long while. Because, see, there's a bunch of pops, no pushes. We still push racks, so that's still wrong. Nothing happened as far as the stack growing, which is worrying. Because there should be a bunch of allocate 8s here that there just isn't. Because we haven't done register allocation. So we have no clue what function, what registers to save. Yeah, see all this, it's so impossible. Just not possible. Because we haven't done register allocation, so no fucking clue. Push them all. Yeah, we're just kind of screwed. There's really nothing we can do here. At all. Because there's no registers. Funcregs is nothing. 0. None in use. Because the function hasn't been allocated registers yet. So that's fun. Yeah, cool. So we can't do this. But we have to do this before this. There's a real chicken and egg problem developing that I don't like. Cool, so we just can't do that. Simple. Cool. Yep, delete all of it. Doesn't matter. Cool. That didn't delete all of it. Cool, you just made it back up for funsies, hmm? Can you get rid of it? Jesus Christ. Yeah, so there's really no solution I see. I know I'm going to look back at this in like a month and go, I'm so stupid, it's so obvious, just do X. But I really don't see anything that can fix this. Why is this? Why did we do this? Can't we just merge these two? Why are these separate? Is there any reason? Am I crazy? Why do we say for each and then switch? Why don't we do... Didn't I have a switch at the top level? Am I crazy? Did I just write... Ah, I switched IR parameter in that way. I didn't switch up IR call. I guess I'll do that stupid stuff before I go, because I don't have much time. I might as well do something. What did we do before? Before we did nothing. So we're just going to write a to-do. sys5 recursive algorithm stuff or whatever. And then really, regardless of calling convention, it registers here. You know, the ones that haven't been allocated yet. Sure. Alrighty. We are coming to a close. What is even... Why? Why have I done such things? So I need to do for each... this part? I just get rid of the switch? Seems ridiculously... Did I just write this? It doesn't make any sense. Am I getting something wrong? Okay, I'm just gonna add this to the backend. What did it even say? Why? Where have I gone? Jesus Christ. Sure. I'm just trying to retain previous functionality. I know it's not ideal. And I'm sure I broke everything and all that broke. So, no reason to do anything. Yeah, that just took me to the fully wrong place. So we have arg count. I'll just do this. Really gotta fix that in this stupid tree sitter mode. I can't believe they haven't done it yet. Can't you make it beginning of line text actually fucking work? Or jumping around by symbolic expression? Like, that just takes me here for some reason? Like, if they plan having this come out in 29, it fucking sucks. Everyone's gonna hate it. More broken code. More broken code. There we go. We ran all 71 tests. And they... only the ones that we expected to failed. How fun. Oh, cool. Just broken. Yeah, that's totally reasonable. What the fuck is happening? These tree sitter modes are so broken. It's making me mad. I'm gonna stop using them. I'm gonna switch back to regular. They look so much worse, but goddamn, they aren't fucking broken all the time. Like these comments that are just misaligned, and this is so fun. Nothing? Okay, no? Okay, you just put them back. Cool. What is even happening? Like, why? How does this make any sense? Why is section text indented one more than this? Like, what is... I'm just even thinking. Yeah, let me just ask a million questions in the mini buffer. That'll be great. If you can't tell, I'm annoyed. Ugh. Simplify lowering of IR call. Sorry, it says just a bit, maybe. Just a bit, maybe. It's just stupid. It's really stupid. I just get angry. I get very angry. They take the time to write out all this useless bullshit that doesn't help anybody. Like, if you take 6 different people writing an article and it still doesn't answer, it still just has nothing. Like, oh yeah, for Kali saved registers, save them. You know, no specification in the ABI of where to save them or how to save them or how it interacts with parameter types that are passed on the stack. No, there's no need to say that. Why would they? Because that would be helpful to people implementing it. So why would they want that? Right? All these 6 people. They can't, I guess they just don't care. It's like, cool. And it's not their fault. It's just that when humans do things, it can't be perfect, and that pisses me off. Because computers expect perfection. They're not lenient and understand what you mean. It's just like, well, you told me to do this thing, so it's not how it's supposed to be, so I'm going to break. And it's so annoying, because people can't tell you. It's documentation in general. Show me a man page that doesn't have shit like this, where it's just like a bunch of nonsense, a whole paragraph that doesn't say anything. There's a million. It's not a Windows thing, it's a human thing. Humans suck at writing documentation for other humans. This doesn't help. It's like, ah, cool. Yeah, just make, it's super detailed about this one part of it. Oh, parameter passing. Oh, but then, this other thing, callee saved registers that you do on the stack. Yeah, just don't mention how to do that or where or be specific about it at all. Just be entirely vague. That's it. Just be entirely vague and say, yeah, it doesn't, nothing. You'll figure it out. It's so dumb. But yeah, I don't know if you caught it, Suraid, but I tried to lower. It just doesn't work because we can't save registers that we haven't allocated. So we're screwed there. We have to allocate registers for the code that saves the allocated registers. We have a chicken and egg problem, and it's so stupid. Suraid says, yeah, we'll figure that out eventually. Maybe. Hopefully in a week I go, man, I'm stupid. I should have just done that. But it doesn't seem doable at all. Just seems like the whole system, how it works right now with calls, don't work. It's like, oh, it's calls don't work. You can't code gen them like this. I'm pretty sure we were just wrong, and it's all wrong. You can't do it this way. I don't think we can code gen parameters of a call at this time. I just don't think we can. It's I just don't know how it'd be possible. Where do we just save and restore every single register? Cool, that doesn't help us. Just made a bunch of shit slower. Doesn't actually change anything. It's so annoying. We should just disallow more than fucking 4 arguments in intercept. If you're doing it that way, you're wrong anyway. If you're trying to call a C function, make a fucking wrapper. I'm just tired of dealing with bullshit. Can we not put sensible limitations? Like 4 parameters? It's fine. Who cares? Nobody needs more than 4 fucking parameters. If you do, you're writing code wrong. This is stupid. It's more annoying that there's an entire spec and there's an entire convention, right? There's fucking MSCon. And guess what? It doesn't say anything about fucking how to save calling saved registers. Just save them. It doesn't matter how, just save them. There's this complex thing called the stack, and there's all this parameter passing that interacts with the stack, and you have to really take precise control of the stack pointer when you make calls. But, also just save registers. Also just do that. It's so annoying. The sys5 ABI is going to be the fucking same. I guarantee it. I'm seriously, I have no patience anymore. As if people are making fun of Windows, I'm done. I lose respect. It's like, okay, you don't respect things that are different just because they're different. I'd say that's really bigoted and stupid. Like, can you just maybe understand things are different in the world? And that's not why they're bad? Being different isn't a reason for being bad? That's all I'm gonna mention. Can we stop with that? It's really fucking annoying. Just makes me not want to say anything or do anything. Like, oh yeah, you guys are just gonna go, oh, you had a bug? It's because you're on Windows. Yeah, sure. I'm tired of it. It's not a joke. It's not funny. I'm just tired. Because I don't think it's a joke to you guys. You guys just actually think Windows sucks because it's different. It's like, it's really sad. Do I think Linux sucks? Because, oh, I don't use Linux and it's different. I don't know anything about it. I don't ever say Linux sucks. I don't say shit when you say you're on Linux. And I go, oh, you had a bug? It's because you're on Linux. Lamau, you probably have to go to the command line. It's like, it doesn't help anyone, and it's not funny. It's not a joke. This is just stupid. You know? Stop making stupid decisions. It's really annoying. If you say like, oh, it's a meme. How is that a meme? Oh, Windows bad, ha ha. It's like, okay. It's not a funny meme, it's just stupid. I mean, I can do that on Windows. What are you talking about, Saray? The reason I think Windows can be worse for programming is because on a Linux system, I can write a C program, run GCC, and it works. It's almost like that's what I do all the time. I use this funky little compiler called GCC, and then I give it C files using CMake, and it builds all these C programs that I run on Windows. On Linux, you would install 10,000 things. You would install GCC. GCC relies on core utils and libgcc and fucking libgomp and fucking everything. It also, you have to install 10,000 things. Just because it comes by default doesn't make it better. It's like, oh yeah, everyone made me sausage, so raw sausage is fucking stupid and gross, and it's worse because it's not cooked. You can cook it. You can't complain. It's not hard to cook sausage. You just download one fucking program, and it's all bundled together. You download MinGW or MSys. It's literally the same as Linux. It's literally the same. On Linux, I can install it in one command using the package manager, though. Crazy. It's almost like there's Chocolatey, which is a package manager for PowerShell in Windows, which has C compilers. It's almost like you can actually use Pacman from MSys2. You can just open up an MSys2, right? And go, hey, give me Pacman. And search for GCC. Is that how I search? I've forgotten Pacman. That is how I search. Would you look at that? Wow, we can just download GCC 11.3 just with like that for MSys. Or for MinGW64, we can have GCC 12.2. Yeah, but it's not exactly up to date, and things like backtraces seem to just not work apparently. What are you talking about? Backtraces? What are you... Are you just bringing up the compiler? Oh, yeah, it requires PDB info. It's because you're using the Win API. Don't use the Win API when you're not compiling with a Windows compiler. That's the only thing. It's an implementation of yours on the platform.c file of the compiler. That's why backtraces don't work. It's not like backtraces don't work at all in MinGW. You can implement them with Dwarf. There's Dwarf debug info in the executable. You can just, I'm just saying, all your arguments are like, oh, you mean the exact same way that it is on Windows? Wow. Pisses me off. It's just different. Stop saying it's worse. Sure, let me quickly just use libdwarf. I'm not saying you should have. I'm just saying you can't blame Windows or GCC or the Windows build environment that is common. You can just implement it differently and it'll work. So it's no one's fault. It's not that crazy. I've programmed on both Windows and Linux. If you're going to say you prefer Linux over Windows and it's been easier for you on Linux versus Windows, cool. That's totally anecdotal. That doesn't make Windows worse. And in my experience, it simply feels like Windows is categorically more annoying to deal with. In your experience, yeah. Why does that make Windows objectively worse? Every time there's a bug, why do you have to go, it's Windows' fault? It almost never is. It's almost always our fault for implementing code in the wrong way or assuming something. Why is a calling convention worse just because it's different and it has a shadow stack instead of, which is basically just 32 bytes required? And guess what? The hardware has a shadow stack. It's called the red zone in x86-64. You have to deal with it all the time in kernels with no red zone because interrupt handlers don't have the red zone, but other times it does. So it's a hardware feature that you're complaining about, and it's just how it's dealt with in the different calling conventions. It's like that's your semantics that's the hill you're dying on. I don't get it. Things like decal spec, DLL import, and DLLs on Windows are just horrible. Are they? Is it different than DL open? I'd say DL open is a simpler API. It's simpler to just like, okay, open a DLL, use it. Call this symbol from within it. It's a function. Get this symbol's value from within it. It's an integer. Yeah? So you could argue DLLs are more annoying on Windows. Does that make Windows objectively bad? I'm not talking about loading DLLs dynamically. Then what is DLL import? Because I've used DLLs on Windows. I use DLLs all the time. Never dealt with DLL import. So if you're not loading them manually, what are you talking about? And I've even implemented dynamic loading of DLLs on Windows for light, and I've never touched import export. Have you ever written a DLL? Yeah, it's pretty easy. You give CMake the shared, add library shared instead of add library static. It's pretty easy, and then it generates a DLL and you call it. I'm pretty sure it's all automatic these days. I don't have to do shit. You can, like, I don't get it. All I'm saying is you can dislike Windows, but why do you have to constantly say everything, every problem I have all the time, everything that is annoying to deal with, it's just Windows, it's Windows' fault. It's like, okay, every bug you bring up, I'm just going to start saying, it's your machine. Yeah, it's just your environment's fucked. You can't do anything about it. It's like, it's so annoying. It's just dismissive. Not every problem you have is because of Windows, but Windows doesn't make it any easier. Neither would Linux. Linux wouldn't make it any easier either. It's just different problems. It's just different. It doesn't make it easier. I promise. There's nothing. It's the same. It's like, instead of clicking 3 times, you click twice. It's like, that's not easier. That's just different. If you think clicking 3 times versus 2 times is a difference in difficulty, I don't understand what you're on about. If you think clicking through an installer and determining paths that way, instead of running a self-extracting fucking archive, is like, they're just different. One isn't better than the other. You can prefer one, that's fine. You're just taking words out of my mouth. Yep, you can make shit up. And then, yeah. Oh, yeah, that would be annoying. That made-up scenario that I didn't say. Jesus. Yep, every time. That's what I was talking about. Instead of double clicks, there's triple clicks. That's obviously what I was talking about. Clearly, that's what I was talking about. That's all I meant. I wasn't saying, there's just a semantic difference. It's not worse. I'm so tired of this, of arguing endlessly with every fucking person. They go, just use Linux. I'm just done. I'm done being nice about it, because you guys aren't nice. You're just, every fucking thing I bring up, it's Windows. It's because I'm not going to look at that. It's Windows. That's Windows, stupid. That's Windows, get away from me. If you don't like Windows, get the fuck away from me. I'm on Windows. Stop saying it. And do you understand? Like, I'm just going to start saying every problem you bring up, it's because you're on Linux. Oh, yeah. Oh yeah, you got to use syscon for some annoying shit like that. Oh yeah, so complicated. Oh yeah, ioctal. Oh, stupid. Can you imagine having to use ioctal? Oh my god. And I'm tired of people saying that Windows MSVC isn't more annoying to deal with. But sure, we can agree to disagree here. That's what I'd prefer. Stop bringing it up. Because I don't fucking bring it up. I don't say, oh, you're on Linux. It's just people constantly going fucking, oh, you're on Windows? Oh, that's why you have all the fucking problems. Shut up. I'm so tired of it. So if you're tired of me bitching about Windows not being more annoying, just stop bitching about Windows being more annoying, and I'll stop bringing it up. But everyone constantly just brings it up. Oh, Windows. Oh, you're on Windows? Oh, it fucking ruins everything. Oh, it's so stupid. And you never have good reasons. You're like, oh, I can download GCC in one command. Like, you can do the same thing in MSys. You click 3 times, you downloaded all of MSys, you open the MSys thing, and you run Pacman. There you go, package manager. Same as Linux. Why does everyone just make shit up and go, yeah, Windows is worse because X? They just want to find any reason that Windows is worse, and it's proof that you're wrong, and you're desperate that you're wrong, and you're going, oh, I can't be wrong, so I got to find this random piece of info and use that as evidence to my made-up, stupid fucking argument. Sarade, yeah, but you have to install MSys first. Yeah, but you have to install Linux first. Yeah, but you have to install apt first. Yeah, but you have to install fucking fuck first. Shut up. Jesus, you just argue endlessly. It's seriously stupid. You go, yeah, I agree with you, but I'm still just going to argue with you. It's like you say you agree to disagree, and yeah, I'm going to bring it up. This is fucking what's going on. Apt is usually pre-installed. Oh, some other guy hit the button for you, so that means it doesn't count. Jesus Christ. Sure, I like discussions. Jesus. It's not a discussion because you're not going to change your mind. You're ingrained. You're finding any bit of evidence ever and going, see, Windows sucks. It's not an argument. It's not a discussion. You're just bringing up your same point for the millionth time that nobody agrees with. And if they do, they wouldn't do it in this way. Okay? Who cares? It's not a discussion. I'm not thinking anything. I'm not bringing an argument to the table and saying, this is how I think it is. I'm saying objectively being different doesn't make things worse. And you're going, see, Windows sucks. It's like, it's so annoying. And then you go, oh yeah, apt comes pre-installed. Somebody else installed this for me. So obviously Linux is better. It's like, so, oh, cool. Cool. How about I give you a Windows machine with MSys on it? It'll be the same fucking thing, right? Oh, it pre-installed. You didn't have to do anything. Cool. And I can do that. Laptops do it all the time. They have custom software that ships with the machine. So you can just do that. You can just ship Windows with MSys or MSys 2 or MinGW or fucking anything on it. TDMGCC. Who cares? You can do the same thing you do with Windows with Linux. Wow, crazy. So it says that you don't agree with. Right. I'm the only person that doesn't agree with you. I'm the only person in the world. Even so, what did I say? Did I say that we don't agree with? We is me. There's nobody else here. It's just stupid. Negative nonsense says, hey everyone, what's up? Mostly negative nonsense. Have you ever had to do networking on Windows? Have you ever had to do networking on anything? It fucking sucks. It's not like sockets or any fucking simpler. And you can do sockets on fucking Windows. It's just different. Oh my God. I'm tired of it. I'm tired of this endless discussion, Sarade. You just keep going, yeah, Windows sucks. See? Windows sucks. Look at all this evidence that Windows sucks. It's these things that suck everywhere. See? Windows sucks. Sockets just suck. They're not simple to deal with on Linux. Have you seen networking code in fucking Linux? It's a bunch of abbreviations and bit flippings and big endian to little endian, and this makes so much sense. It's all confusing. It's just different. Can we stop with this shit? Jesus. It's not different. It's like, okay, cool. It's so much harder just because you used the other one. Maybe if you used Windows first, it'd be easier. You ever think about that? That it's just your current perspective that makes you go, oh, I use Linux all the time, so I happen to think Linux is great and Windows sucks. Oh yeah, and I barely use Windows and I always use Linux. It's like, obviously, it's just meeting your pre-assumed assumptions. You're not... I've programmed on Windows for years. I've programmed on Linux for years. All my programs are for Linux and Windows. I don't hate Linux. Linux is annoying, so is Windows. There's no difference. They're different. There's no difference in difficulty to use one or the other. And you have to admit that if there is, it's just you. It's your experience. I'm just tired of everyone fucking endlessly going, Windows sucks for no reason. Fuck off, okay? Fuck off. All your arguments are wrong. They're stupid. Seriously, that's your reasoning is like, well, this one API sucks. Well, ioctl sucks. Sysconf fucking sucks. Everything. There are so many APIs that suck on Linux. And there are so many APIs that suck on Windows. APIs in general fucking suck. Can we stop blaming Windows? Please? And if you do, I don't care. Don't do it into my fucking face. Every time I bring something up. I'm sure your anecdotal evidence fits your viewpoint that you already had. That's not shocking. It's not shocking that your experience goes, well, with my experience, the idea that I already thought, I still think it. I know. That's not what I'm arguing. I don't care. You just have to admit that that's your own opinion and it's personal and different from person to person. That if you grew up on Windows and had the person who fucking made Windows describing to you, hey, here's how this works. Here's how to do networking. Do you think it'd be difficult? No, it'd be easy because you were taught it forever since you started and the person who made it helped you do it. Windows sucks. It's like, okay, yes, Windows sucks to you. Can you stop mentioning it every time someone says one fucking thing? I didn't bring up Windows. I don't bring up Linux. I never bring it up. And if I do, I go, oh man, this is being so annoying. I bet you on Linux this would be easier. Because that is how it is. The APIs on Windows that suck aren't the same as the APIs on Linux that suck. So it's different. Oh, this particular thing is easier. It doesn't make Windows better. It doesn't make Windows worse. It doesn't make Linux better. It doesn't make Linux worse. And Surreyed flip-flops from earlier. Well, the calling conventions are annoying on both. That's right. Finally. I'm glad. I agree with that. That's what I've been saying this whole time. Stop calling it Windows' fault and saying you can't do shit because of Windows when it's your fault. They're the same. They're just different. That's it. If something is worse to deal with on Windows than Linux, then I'm going to bring it up. Well, it'll be brought up to no applause. And no one will like it. There you go. Semicolon says, holy moly. But seriously, I'm going to ban the term Windows moment in this damn chat. Anyone who says it's going to get a 10-minute timeout, I swear to God. It's going up. It's going down for real. Semicolon says, I've been more surprised by similarities. They both work very similarly. See, Sarade, it's just annoying. You argue endlessly that Linux is good, and you argue endlessly that Windows is bad, but as soon as Windows is good is brought up, you just bring up Windows is bad, and as soon as Linux is bad brought up, you just bring up Linux is good. It's not a discussion, you just keep saying the same shit. Do you understand why that's annoying or a problem? It's like, yep, you think Windows sucks, you don't need to bring it up to this unrelated thing. Can you just be honest with yourself, maybe? And say, oh, I can't do this because I don't have time? Not go, oh, it's so funny, I didn't do it because I said I hate Windows. We all know! You can bring it up, it's just people aren't going to like it. You're making people mad, like me. It's just dumb. Mr. Couture says, Lenzer, I think the chat may be getting to you, bud. Don't call me bud. You're not my buddy, you're not my friend. I don't know who you are, Mr. Couture. The chat may be getting to you. I think it's just life. I don't like people in general. Sarate says, my take is that all software sucks. Windows is just generally more annoying. That's fair. That's your take. Can you stop saying that it's my fault that I'm having bugs, or that you're not going to, oh, I won't do that because it has anything to do with Windows? It's like, are you that ignorant? You're just going to, oh, that has to do with Windows and I'll never learn about it and it's stupid and complicated and it's worse, so I'm not going to do anything. And the best part is when you said that, it wasn't even anything that has to do with Windows. It's just that you're listening in the background and went, oh, this'll be funny. I'll say some bullshit about Windows. It's not funny. It's not, why are you mentioning it? We were talking about caller-saved registers, and you're like, oh yeah, I would look at that, but it's fucking shadow stack, so stupid, Windows, am I right? Like, I don't care. Jesus. I'm just done with people in general. I'm done trying. Bitwitch says, I picked a spicy time to drop in. What are you working on at the moment? Nothing, because it's all broken. We did implement a lot of the MS Win ABI x64 calling convention, right? And we just can't, we hit a wall because we can't go any further. We have to save registers that haven't been allocated yet, so we don't know what registers to save. And if we wait till after register allocation and when we're emitting the call, guess what? We can't fucking touch the stack because now we have allocations on the stack that are parameters. So when we push these, then it's now treating these saved registers. It's saving them. And then it's just treating those, because of the calling convention in the function, it's treating those as the, arguments. So we have this function which takes 8 arguments, and it thinks that 4 of them are on the stack, and it's going to see nothing. It's going to see this garbage on the stack right here as the 4 arguments. And it's just the order that we do things in. So all these allocates, right? These pushes just can't be here. They just can't happen. So it's like, oh yeah, just do this without any pushes. Yeah, again, I think a lot of this is because of lack of instruction selection and the RA still being a bit scuffed. I don't see how that has to do with anything, but yeah, sure. It's just the stack pointer. How would instruction selection fix it? Because saving registers is fundamentally an RA issue, so ideally when we emit a call, we shouldn't even have to care about that part. I mean, ideally, we shouldn't have to care about registers at all. Ideally, there's not 2 address instructions that make us have to fucking bend over backwards. The world isn't ideal. World sucks. Middle Cloud says, hi, what's up, Middle Cloud? How's it going? I'm just angry at the world. I'm not angry at any particular thing. I'm angry at everything, because everything sucks. And every interaction I have just proves to me more how humans suck, and how everything is the worst, and how nothing is fair in the world, and everything will always be the maximum amount of annoying. That's why I get angry. Okay? because the world keeps proving to me how much it sucks. It's like, oh, you thought this was going to go well? No. And that makes me mad. So, when you say chat is getting to me, it is true that someone in chat said things that made me angry. Chat, you could say chat's, it's getting to me. I don't think chat is getting to me. I think the world is chipping away until it exposes something and it goes, oh, look, we can rush in here. It's like water. It's like limestone being exposed to water, right? And it just goes, starts fizzing like crazy and eating away. That's all. It's little chips. You're right, Saraid. I should just give up and never be angry and just accept that the world sucks. I'll be so much happier. I'm not saying that's your fault. I'm just saying it's not a solution for me. You can just give up and you don't care. Cool. I don't. I can't. You can't just give up. It's pathetic. Mr. Couture says, I kind of agree. Too much code degrades into chaos. Sure, I don't know what you're agreeing with or who. I would agree. Humans just make shitty things. We're not perfect. Even groups of us, I'd say groups of us are even less perfect. And we just easily miss obvious things like doing all this completely fucking stupid so that it'll never work. You know? And there's just no solution. I don't see a solution to this. When can we do this? We can't do it before we lower, because guess what? That means that the stack pointer it's not correct at all. So it's all stupid. It's really all stupid. Mr. Koter says, like these registers that someone didn't simplify somehow. Even if you can't simplify it, all they have to do is make it fucking clear. All they had to say is, allocate, every function has 128 bytes allocated to save register, caller saved registers, and it's here on the stack at this spot. Just define it. If you're going to make us save and restore registers, why do they make us make up a way to do it? If you're going to go to the fucking trouble of describing this lengthy, detailed description of how to lay out the stack perfectly for every fucking function call, and then you just go, oh yeah, and by the way, there's also this other thing that interacts with the stack. You have to do it every time there's a function call, and good luck implementing that. We're not going to tell you how. It's like, are you serious? You go into super ultra detail for this one thing, and then this other thing you just give up? That's what bothers me about this. Like, they know this. They've had this problem. Mr. Couture says, right, exactly. It seems like a trap, lol. Exactly. It's like, oh, that's not, what do you mean? It's just, it doesn't make any sense. It doesn't make any sense what they've done. And it makes me fucking mad. Because guess what? I'm not the first person to implement this stupid fucking ABI. I'm the millionth. I'm the 10 millionth. I'm the 100 millionth. I'm not the first. 6 people wrote this fucking article. I'm guarantee at least one of them understood enough about it to go, hey, these all go in the stack. And it matters like how far they are off of the stack from the base pointer. And then we just tell them to save registers and we don't tell them where. So they're probably going to use the stack and then it's going to fuck everything up. But no, they just go, they'll figure it out. It's so annoying. It's like, oh, cool. Yeah, I guess I will have to figure that fucking out. And then you have people in chat constantly telling you, oh, it's good. Windows ABI sucks, see? It's like, it's more complicated on Linux. Have you seen the sys5 ABI? It's 130 pages. Okay? It's not simpler than this. And they didn't even take the time to describe call or callee saved registers or when to save them or where they should be saved. They say the same shit here. They go, yeah, these ones are volatile and you can't rely on them being saved. That's it. That's all they say. It's so annoying. It's stupid. It's like, and they don't care is the stupid part because they still make their money. So who gives a fuck? Why make things better? It's America. So it says, seeing as people have been developing calling conventions ABIs for literal decades now, I'd hope that this is mostly for performance reasons. I'd say it's less performant to leave something up to the implementation because they can just do anything. If you have a specification, specify how to do something, the actual implementation of it, as a performant implementation, and then they'll all be performant implementations. So performance would be the best. Right? Why would making it not undefined and just going, these ones are volatile, good luck, why would that make it better? Mr. Couture, exactly. No. This is just decades of people coming and going from the code base. Exactly. So it says, well, that presupposes that you know what the best implementation is. Well, if it's for performance reasons, then you would know the best implementation. Leaving it up to the implementation can help make it more performant. So can defining the implementation in the spec, or saying, here's a recommended implementation. Here's what we did. Here's how we thought that this would work. They just don't do that. They just say, yeah, fuck you. It doesn't have, they don't have to give you the implementation. All they need is an example. I don't care if it's the best. It'll never be the best. That's the whole point. Oh my god. I'm going insane. An example of this is how MSVC does it would make sense, I agree. Everything suffers from a lack of examples. Sys5 doesn't have any fucking examples. Are you kidding? It's a 130-page PDF, the Sys5 document, and it doesn't have anything of examples. It just has endless fucking paragraphs of text. I've read it. I opened it today. IIRC has some neat tables, though. This does too, to be fair. If tables are high-tech and fancy, we're done. We're done as a human race. We probably already are. The world ended about 50 years ago. It's already done. But yeah, so none of this code is probably ever going to be used. Because it just can't work this way. We're just going to have to rewrite everything. I just want to restart. It's not going to be better. That's what makes me so mad. Just because I've done it before doesn't mean I'll do it better next time. I'll probably just fuck up in the same ways or worse. So it's better to just rewrite what you have. But rewriting what you have is fucking annoying because you spend 18 hours on something and then you go, yep, it does 1/10 of what it used to. Fun. But yeah, I really don't see any solution. I've been sitting here for an hour and a half. I don't see any fucking solution to this. I just want to give up. It's like, ah, cool. Yep, we can't know what registers to save, and we can't save registers once we know which ones to save. Yeah, I have no clue when to do this. How do you think I felt when I was first figuring out how to do RA? Not great, but at least you have fucking something provable. This is just, there's no even proof that this will ever work or can work in this way. You had like a book that says, hey, if you collect all the live ranges and you iterate them in this way and you color them like this, it works. You had the example. There is no example here. It's just broken. And there's no proof that the current system will ever work or can work. So it's like, do we spend time making the system better? Do we spend time changing how IR call is emitted? Do we change it how it's code genned? Do we change, it's like we can change any variable and all of them take 10 hours to implement. So it says, yeah, that book was about as detailed as MSDN in its description of RA. No. Still, it's just, there's proof that it works. There's math. There's no math here. Just stupidness that I've done. Mr. Couture says, for me, a lot of times I think of great solutions when I'm not on the PC and come back the next day. I mean, yeah. I just, normally I think that. Normally I go, this is a hard problem, but I'll think of something. I don't feel like I'm going to think of anything because I don't know how to solve this or what to do at all. I don't know how to debug it. I don't know how to start making progress. It's just like, oh, what if you just didn't do everything you did now? It's like, it feels like it'd be easier to just like, just delete all this. Yes, just delete all this and never fucking do any of this because it's never going to work. That's how I feel right now. I don't feel like, man, if I spend 3 more days thinking, I'll be sure to come up with an answer. I don't feel like that. I don't have any idea where to start thinking. What do I do? Like, oh, cool, I can't do anything here. It's just illogical. It doesn't work. When I need to save the registers, I don't know which ones to save. When I know which registers to save, I can't save the registers. It's just, logically, it doesn't work. There's nothing that's going to fix that. I can't just magically go like, what if that wasn't the case? Like, yeah, that'd be great, but it's not. It's just not going to work. It's all broken. If it's a pain, don't do it that way. I mean, I just can't do it anyway. It just doesn't work. It's just dumb. The system I came up with is illogical, false, doesn't work. That's what it feels like. It's like, I don't feel like I can fix this just by, rearrange some things, move things. It's all just broken. I gotta stop being so negative. I'm just in a bad fucking mood. But yeah, I would love to not do it that way. I have to go. I gotta leave at 7:30. Middle Cloud says, from experience, if a developer has a problem and you don't understand the code in 10 to 15 minutes per chunk of code, you will not understand the next hour. You need to jump to another part. I mean, even if it is, when did you write that code? 2 months ago? I don't think you were considering this problem, so if it doesn't work with that, then that's not even that surprising. You can always plan ahead for everything. I can't even picture a way to change the code to make it work. I agree. It would make sense if, all this code, I gotta delete it and rewrite it in this other way because it doesn't work in the way that I thought it would. But no, it's not like that. It's just that I logically don't know how to write the code. If we wait till register allocation, then there won't be registers allocated for the code that actually needs to save the registers. And if there isn't any registers that need to be allocated, how did we do that? You know what I mean? It's like, oh, then you magically stored registers into memory. Where'd you store it in memory? Well, where'd you allocate that memory? This doesn't make any sense. Calvin Coolidge says, is it possible to just save all registers and start there? That we can't. That's the problem. We can't save registers when we save them. Currently, in an IR call, we're saving registers by pushing them and then popping them. That's how we restore them. We can't do that. That's against the ABI. So we can't do that. We can't push or pop registers before and after a function call. So we can't save any registers or restore any because we can't save any. And the reason is because push alters the stack pointer and we have parameters on the stack. So we're fucked there. But guess what? What if we just go and okay, what if we don't push them here? What if we push them before we allocate the registers on the stack? Right? Well, here's where the parameters are allocated on the stack. Right? This is the part of the ABI that needs to be bunched up next to the call and why we can't push things after we do these. So you think, oh, we just go before this and we just save the registers. Oh, wait, which registers? Where? It just doesn't make any sense. So we don't know which registers to save. Even if we did save all of the caller saved registers every time and restored them, where? On the stack? So we just make a stack allocation here, but then there's a bunch of stack allocations here that have to do with the ABI. So effectively what that means is that we'd have above the parameters, we'd have the registers. So then when we restore them, we'd have to restore from some arbitrary pointer in memory. Where does that pointer get stored? Is it the compile time known offset? If it is, okay, let's say we can save all the registers every time and restore all the registers every time. That's horrible. That's not performant and not the right way to do things. Cool, we've implemented the worst possible way to do things, and it's not performant, and it'll likely cause even more bugs. Because what about when RDX stores a return value? The high 64 bits in sys5 ABI. RDX stores the high 64 bits of a 16-byte return value. RDX is a caller saved register, which means RDX would be saved and restored, and the return value would be gone. So then this has to be a dynamically sized amount of registers that are saved. And then we're still saving 7 registers every time, every function call, which is just not okay. It's that's the worst code in the world. And it wouldn't be 7 registers, it'd be 10. Right? The caller saved registers. Spilling generally involves creating local variables. That's also why I didn't implement that in the RA initially, because that seems like it's kind of annoying. Very annoying. And then, here's the thing, with that implementation, we can never optimize it. That's the issue. We never know what to fucking optimize. Okay. Calvin Coolidge, I was thinking once register allocation occurred, we could optimize out the saving of registers that weren't live, but with the return value issue is a pretty big issue. Right. And after RA, it would change which registers are live and not based on if they're actually used in these instructions, in these allocates, and, right? Because we'd have to actually store an IR register hard-coded into the allocate, which means that then the register would have to be used, which means it'd have to be... It's a mess. I don't know. Beta and Coors, thank you so much for the follow. I gotta go. I don't have time. I gotta go. Thank you everybody so much for watching. Check out the Discord. There's announcements every time I go live. Thank you so much, Hells and Neutrino. You joined. What's up? Thanks, everybody. I really enjoy it. Can I get notifications roll? Yes, you can. Thank you, May. Thank you, Hells. You now have notifications every time I go live. How beautiful. Hopefully next time I won't be so mad. This is part of why I'm saying an MR would help. That way every instruction would know register copies, what register contains, blah, 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 and everything could just be handled for each instruction individually. I hate it. I hate that the solution is like, what if we just make another level of abstraction with a million more opportunities for bugs and make it 10 times as hard to maintain? And also, it lets us fix this one specific issue. It's like, can't we fix it in any other way? I hate this. I hate it. Join the Discord. Go to my YouTube and click the subscribe button. I have over 1,000 now of you fuckers. I don't know why. I don't know why you watch, but I appreciate it, okay? So thank you. But there's all my VODs. Every stream I do is up there. There's 9-hour-long videos. Rosic says, what you making? It's in the title, a compiler, and I'm going actually now. I made a compiler. It doesn't work very well. We made a PR today, that broken code. Complex params, how fun. It's not even a PR, it's just a branch. So yeah, check it out. Check out my GitHub. Check out my Codeberg. I have an entire OS. If you are here and you don't know that, you should go check it out. I have an entire OS. It's fun. It's fun. I have a compiler, an OS, a text editor. Go check out all these things. How hard is it to rewrite to a new implementation as fast as possible? I'm not sure what you're asking, Middle Cloud. I do want to answer you. How hard is it to rewrite to a new implementation? Like, are you going to say if I rewrote the compiler or the OS? A year. I don't think rewriting things helps at all. It just, you're going to make more mistakes or the same mistakes. Nothing ever gets better in an entire from scratch rewrite. You can rewrite sections. Serraid, or rewriting everything would take a while, yeah. A long time. Months and months. Middle Cloud says, so you have a problem with a part of code. Definitely, yeah. You're going to have to check the VOD, because I got to go or I'm going to be late. Thank you everybody so much for coming. Check out the YouTube. There's VODs of all shapes and sizes, short ones, long ones, fun ones, fat ones, skinny ones, thin ones, thick ones, all sorts of ones. So go check them out over on the YouTube. Be sure to join the Discord if you want announcements every time I go live, or just to say hi and ask questions, get help with your code, do code review, mention things. We all have a ton of fun. Linguistics. Hopefully next time I'm not so mad. I'm working on it, but the world is also working on making me mad. So it's a balance. I basically am fighting the universe to stay angry, stay unangry. But yeah, thanks everybody so much for watching. Check out the YouTube, check out the compiler. I'll be back here probably tomorrow doing more stupid shit. Try not to think about everything that I've made that's broken. And yeah. I'll be back. Message me on the Discord if you have any specific questions. That's all I got. Thanks everybody so much for watching. Thank you, Serraid. You're awesome. I appreciate you dealing with my stupid ass. Middle Cloud, you're awesome. Thank you so much. If you don't know, Middle Cloud is the most recent contributor to the channel. We appreciate Middle Cloud so much for helping keeping this whole thing up and running. Bye, Middle Cloud. Bye, Serraid. I'll see you another time. Hopefully we can not, hopefully we can implement something that works next time. Bye-bye.